hour and 15 minutes long. So we're going to go ahead and start back here at about 10:45 Central Standard Time. So that's in an hour and a half. That'll give you an extra 15 minutes or so to enter back into the class. Actually, just to be safe, I'm going to make it 10:50 to give people about 20 minutes extra for those that are coming a little bit late. So make sure you copy and paste that video link into your web browser. Once it's opened up and you're able to start the video, you can go ahead and exit out of the call. That also lets us know kind of who all's been able to successfully start the video. Once the video ends, we're going to have you come back at 10:50 for the first Q&A session. All right, for those of you that joined a little bit late, we will have the Zoom call here will be used for our Q&A time. Hello. And then also sharing the video links and the quizzes. We've just shared the first section video link in the group chat feature. So if you open that group chat up, you'll find that first section video shared there. It's a YouTube link. You can copy and paste that link into a web browser and then go ahead and watch that video. Once you open that up and paste it in, then you can go ahead and exit the call, and we will start back up at 10:50 Central Time with the first Q&A session. Hello and welcome to PureTech's helical pile training and certification class. My name is Michael Wilkes. I'll be hosting the event today. Thank you all for attending. We're going to cover quite a bit of material in a short period of time. Make sure to take good notes. At the end of each section, we're going to have a short question and answer time, followed by a quiz on the topics we've covered. So the first section includes an introduction to helical piles, and then we'll cover the terminology of the helical pier, along with applications and markets for the product, and then wrap up with the advantages of a helical pile foundation over other types of foundations. I want to start off the class by showing a video on PureTech and our helical pier system, along with helical piers in general. So please enjoy.
For almost 2 decades, PureTech Systems has been leading the helical pile industry through innovation, technology, and excellent customer service. PureTech continues to deliver high-quality products into the residential, commercial, and industrial markets. Some applications include foundation repair, new construction, oil and gas, decks, boardwalks, equipment foundations, utility and transmission towers, high-capacity piles, light pole bases, shoring, tiebacks, and limited access spaces. The major problems that contractors face are poor soil conditions, unstable foundations, and cracked and buckled walls. The solution to these problems is the PureTech pre-engineered foundation system. The process begins with qualified engineers performing site and soil analysis. The engineers will then specify the correct helical pile for the job. Occasionally, a load test may be performed to verify the load-bearing capacity. This produces a verified site analysis. The manufacturing can now begin. PureTech Systems manufacturing facilities use a rigid quality control program that conform to ICC protocols to ensure our helical products meet industry standards. PureTech's helical piles and anchors are manufactured with high tensile and yield strength domestic steel. Some of PureTech's advantages are the patented cross-lock connection, which features instant alignment, providing full steel-on-steel loading, while all torque is contained in the connection. So there's never hole deformation, as neither the torque or compression load ever reaches the bolts. Consequently, the installation contractor saves up to 50% in labor costs. Our patented True Lift bracket, unlike most foundation repair brackets, is lightweight, easy to install, can be installed with or without anchor bolts, and is virtually moment-free. The PureTech Hercules pile is a large diameter helical pile that delivers a load capacity in excess of 500 tons. No project is too big. PureTech Systems helical piering equipment is designed and manufactured specifically for the helical pier industry. We offer many specialty connections, drive tools, and the innovative TrueLink torque monitoring system. We provide free training seminars every month for contractors to become certified PureTech installers. All of our installers are valued members of the PureTech family. And it doesn't matter whether you're brand new to helical foundation construction and repair or an expert, we can support every aspect of your project with relationships built daily, quick deliveries, free training, extensive inventory, and a 24-hour contact line. You'll receive the exceptional customer service you deserve. PureTech Systems, driven by innovation.
All right, so that is a little recap and background of PureTech along with helical piles in general. So now to get into the meat of the presentation. Helical piles have been around for nearly 200 years. They got their start in the early 1800s being used for lighthouses and boat moorings. So at that time, large steel cast helixes would be bolted to timbers and driven in by sheer strength. At that time, there was no hydraulic motor. It's advanced quite a bit with the hydraulic motor over the last 100 years or so, and really in the 1980s is when you saw a resurgence of the technology used for foundation repair, commercial construction, new construction, and now into the high-capacity Hercules line. So PureTech, we got our start around 20 years ago and really found a spot with innovating the product and providing great customer service on it. So with our round shaft piers, we were one of the first in the industry to manufacture a helical pier on a round shaft. We also have innovative connections. So our cross-lock connection is patented. We'll get into that a little bit later. And our True Lift bracket is patented as well. We're continuing to innovate and really be with the contractor and understand their pain points to make it better for them and for the engineers out there using the product. So helical piers as a whole have been around since 2009 in International Building Code. That's really important. Remember that. That'll be on the quiz at the end of this section. So since 2009, you can find a provision in Chapter 18 of International Building Code and really talks about all the design elements to designing a helical pier foundation. Really what it comes down to are three basic components in a helical pier. You have the lead section. That's the first section that goes in the ground. And then the extension sections follow that until you reach your torque and depth. And then some sort of bracket to connect the pile to the structure, whether it be a bracket that's cast into concrete or a saddle bracket that's bolted to a timber for support of a deck, or perhaps our true lift bracket for underpinning an existing foundation. All of those are acceptable termination brackets to use. So here's some terminology. The lead section, again, is the first shaft section to enter the ground. Okay, that's important. It's the first section. Remember, that's going to be on the quiz. That's called the lead section. Again, it consists of one or more welded helical bearing plates. All right, so on the right side of the screen, you can see a diagram showing a single lead, a double lead, or a triple lead. And that means that a single lead will have one helix, a double lead will have two, and a triple lead will have three. All right, single, double, and triple. Length of those lead sections typically run in the 7-foot length, and we can make them in 5-foot, 10-foot, or a custom length outside of that as well, based on your reach and your limited access scenarios. So the helix plate itself is very crucial to the helical pier. It's important that that helix be pressed into a helical spiral. That plate is pressed into the helical spiral, and that plate will follow itself around the entire length of the plate, so that as that pier goes into the ground, it threads into the ground and it doesn't auger into the ground. That's very important. So every helix has a standard pitch, and the pitch is the distance between the leading edge of the blade right down here to the upper edge of the blade at the top. So that distance for all the small shaft diameter piers, 3.5 inch and under, will cover the 3-inch pitch. So your first check as an installation contractor is to make sure that every time you spin that pile around 1 revolution, that it advances in the ground approximately 3 inches. That's very important. Next, the helix thickness. So the helix thickness is standard for 3/8 inch on anything less than 3.5 inch OD. All right, both of these are going to be on the quiz. 3-inch standard pitch and 3/8 standard thickness. Next is helix spacing. So how do we know what spacing the helixes need to be placed for multi-flight piles? Well, they're spaced at a 3 diameter spacing, 3D spacing. So that means that if the first, on this double lead over here, if the first helix is 8 inches and the second helix is 10 inches, the distance between those two should be 8 inches times 3, which is 24 inches. Okay, so there's three diameters that you'll go through by the time you get to that second helix height. And it's very important that these are timed in such a manner that when that second helix enters the ground, it enters the ground at the same point that the first helix did, so that it follows itself and threads into the ground and doesn't auger out the ground. Those are very important points to remember. All right, next we have the extension sections. Those are added length of central steel shaft, either a solid square bar or a round tube, round hollow tube as you see here in the pictures, with a coupling that extends the pile. Right? So the typical lengths for those extensions are 5 or 7 foot length. We can make custom lengths as needed. Next, we have the coupling. The coupling can either be welded, pre-welded to the pile, that's the most common version, or it can be bolted on in the field to both sections of pipe. So we'll talk about our patented crosslock coupling a little bit later, but those are typically bolted to the pile. The most common question we get is, what torque do those bolts need to go onto? They just need to be snug tightened enough to where they won't loosen in the ground. So if you grab a couple wrenches and pull tight, that should be plenty of torque for the bolts. Next, we have installation torque. This is really what makes the helical pier so powerful, is the fact that you can measure the amount of shear strength in the soil by installing the pile. So you're getting good strength information about the soil through installation torque. It allows us to use lower safety factors than other types of foundation systems, and acts as a very good quality assurance program when we go to install the piles. Next, we've got the torque rating. So the torque rating, every pile has a specific torque rating, and that's based on the shaft diameter. That's very important to remember. That'll be on the quiz. So the torque rating itself is based on the diameter of the shaft, all right? The overall outside diameter of the shaft. This is an example of a torque test being done in our laboratory to failure, so that we can see at what point and what we can rate that torque rating at. I usually recommend you stay at least 80% or so away from the max torque rating in your design, so you give yourself some wiggle room in case you hit a hard layer that you need to get through. Next, we have down pressure or crowd. Crowd is very important for pile advancement. You want to make sure that you're applying enough down pressure to the top of the pile to maintain that 1 helix pitch per revolution of advancement into the soil. So you want to be starting that pile to where it bites and it starts to thread into the ground. This picture here on the right side, you see an excavator that has pretty much all of its weight on top of the pile. That is very atypical. Most scenarios, you do not want to do that. You want to keep your tracks on the ground. You don't want to over down pressure. Most likely in this installation, they had a hard layer of soil that they were trying to break through and get the pile to bite. And then once it did, they would release the down pressure because the pile would have enough force on its own to thread into the soil. It's also important to understand loads and what loads you should be looking for when you're reading a plan set that you may get from an engineer. The load we use typically in helical pier design and what's used for International Building Code is called the working load or service load. It's the total magnitude of unfactored loads determined by the owner's representative, typically an engineer, that must be resisted by the piles. So it's all the dead loads and live loads of the structure. Next, we have the factor of safety. Factor of safeties are very important. An engineer will apply these to the working load to account for unknown factors about the soil strength or steel strength or the actual load itself. Typically, for most shallow foundations, slabs, footings, you'll see a 3-to-1 safety factor to the working load. Helical piers, again, because we have installation torque, we're typically allowed to use lower safety factors. For the 1.5-inch diameter to 3.5-inch diameter helical piles, we typically use a 2-to-1 safety factor. Again, this is very important. This will be on the quiz. We typically, for small helical piles, use a 2-to-1 safety factor, 2 times safety factor. So the working load is what we design to, but what we install to is called the ultimate load or ultimate resistance. That is the working load multiplied by a factor of safety. The limit state is based on the lesser of the mechanical strength of the pile itself or the geotech capacity of the pile. Typically what you'll see is it's going to be the geotech capacity of the pile is going to limit your ultimate load capabilities. I'll explain this a little bit more in detail later. So let's do an example. So if you have a working load of 20 kips, what is the minimum ultimate load for a helical pile shaft? Well, you take the ultimate load, or you take the working load and multiply it by the factor of safety. All right, so you take 20 kips, and we know for small piles we use a 2-to-1 safety factor. So you take your 20 kips and you multiply it by 2. That gives you an ultimate load requirement of 40 kips. So now you know what load you need to install to. In the next section, we're going to explain how to calculate what torque you need to install to once you know that load, that ultimate load. All right, so those are some basic terminology. Now I want to move on to applications. These are different projects and markets that our installers have, over the years, have developed and started to use helical piers in. So back when PureTech started, maybe half of these existed. Now maybe even more than are on this list are out there. So we're gaining new applications in markets every day. So if you want to start up in the left-hand corner with me, the signage industry has a lot of good applications. We've been involved in sound wall projects with helical piers, roadway projects with breakaway signs or billboards, billboards with large pile caps with multiple helicals installed inside of them. Again, the benefit there would be if you have high groundwater table or collapsible soils that makes it difficult to auger out a large concrete pier. Moving down to amusement, there's a lot of applications in amusement within parks, local parks, athletic fields for bleachers or backstops. The circus tents, you can use helical piers to tie down those. Golf courses, stadium projects. We actually were involved on a stadium project at the Philadelphia Phillies the last couple of years, and with one of our installers. So this was a project that came to us. They wanted to use helical piers because of the low vibration, low noise. They're installing very close to existing structures here, so that's all very important. Here's some design details that were used in the project. As you can see, we installed 3 to 4 pier groupings within this project, and the piles were cast within the actual pile cap themselves and tied together with a rebar bed. And all that, the columns were sat on top, were placed on top of those pile caps. One thing we did about this on this project that you may be involved with some commercial work are site-specific load tests. And this involves installing a center test pier and then 4 reaction piers along the outside connected together with 3 beams. You can see 2 of them in this picture. There's 1 beam going across the center of the load test and then 2 beams that tie those anchors on each side. So once all that's set up, a calibrated cylinder is placed in the center along with a load cell, as you can see here. So the engineer right here is adding pressure to the cylinder and adding load. And then there are small dial indicators that are attached to these steel angle pieces. Those are measuring the deflection in the pile. So the load will be applied in increments and the deflection will be read until the maximum deflection or maximum load allowable is reached for the pile. So that's the test. It usually takes about a couple hours to set up and about 3-4 hours to run a typical load test for a small helical pile. So this allows a engineer to be more confident in the design and in the safety factor, and also allows you to economize the design and make sure you get the best pile for that specific site. Moving on to some other applications, we have the electric utility market. This is a very old market for helical piers. It's been around since the early 1800s with guy wire installations being one of the first applications for the early helical pier. Since then, we've added a lot of additional with tower foundations, transmissions, substations, wind generation, anything the electric utility industry, you can pretty much use a helical pier to support it. Here's a really cool, interesting project we were involved in last year. This project was a remote installation. It required a tower to be supported, and because it was remote, it would be too expensive to haul concrete out there. So they came up with a helical pier design. Each one of these tower legs had 3 helical piers underneath it, as you can see here in this picture. All right, and those piers were installed at a slight angle. All right, you can see this. I'm tracing that right there. Probably installed at about a 20 or 30 degree angle. This was very important because that angle allowed us to carry all the side load and shear load of the structure, allowing us to use smaller diameter piles. I believe this was a 5-inch diameter helical. Moving on to some other applications, the marine application, again, a very old industry for helical piers. Newer markets for that include bulkheads, boat moorings, and then other types of marine construction inland with docks, boathouses are now starting to become a lot more popular use for helical piers. Again, the fact that you don't have to have that vibration or noise of pounding in piles. You don't have to worry about the issues with digging a hole with high water scenarios, and the piles can have epoxy coatings or polyurethane coatings. I'll cover a little bit more in detail later, added to the pile to help prevent it from corroding. Then we got the telecom industry. That's a smaller industry, but a lot of those cell towers have been built at this point, but additional service is being added to the towers. And that additional service requires additional load capacity. So you can come through an existing tower, underpin it with a helical pier, and add that additional load capacity. Down to the bottom there, oil and gas, that's one of our largest industries. You've got refinery, pipeline work, pump jacks, all the equipment pad foundations can be supported on helical piles of different sizes and ranges, from our small 2 7/8 pile up to our Hercules pier. Moving on to some government applications, you've got airports, bridge abutments for helical piers. Down in the parks area, you've got boardwalks. Boardwalks are very large for helical piers. You can install a lot of piers in a very short period of time and have very minimal impact. So they're a green installation product, are helical piers. Moving down, you've got roadways. We've been involved on a lot of Amtrak projects with platform stations using helical piers. And at the bottom there, wastewater treatment facilities. A lot of these facilities are very heavy structures, and they're built on sites that are typically poor soil conditions. So a lot of these need pile foundations, and the helical piers are great for them. So here's a project we did several years back. This is a 4.5-inch pile, and they were installed about on 6-foot centers for these large mat equipment areas. So the piles were installed, cut to elevation, pile caps placed on with some rebar, and then poured through. Again, these are very big projects in the hundreds of pile range on some of these. All right, moving on to industrial. We've been on a lot of cool industrial sites over the years. The great thing about the helical pier is it limits the downtime and shortens the construction schedule. So with a existing factory that runs most of the days out of the year, and they only want to be out certain days, you can go ahead and block that schedule off, go into the factory, core out the concrete slab, install the helical piers, and directly attach the equipment to them. There's not a lot of other foundation types that you could say it could do that, and do it all with equipment that accesses limited access areas. Moving down to commercial, there's a lot of commercial applications for helical piers. in retail. We've done some standalone retail structures with McDonald's and Dollar General. Elevator pits, so retrofitting old commercial sites with elevator pits. Elevated parking structures. Here's a project we did a couple years back with an elevated parking structure. This is our 10 3/4 diameter Hercules pier, and they were installed in 25-foot length sections with this large cat excavator. And that's a 300,000 foot-pound drive head installing them. So you can see we did a load test on this for a static load test and a dynamic load test, and proved out a nominal ultimate capacity of 168,000 pounds, or 168 kips. So you can do multi-story structures with these piers. This was a 5-story precast building. All right, next we have soil control. Soil control, a lot of specialty applications within that with slope retention. This is big out in the West Coast right now. A lot of issues with retaining hillsides, so the piles can be used for that, along with other types of tiebacks. And then different miscellaneous with specialty lighting is one I want to point out there. Helical piers work great as light pole bases, so you can screw the piles in. They're made with keyways down the side that you can go ahead and put the electric up through. And the top of it has a base plate that matches the light pole base. So you just screw it down and bolt on the light pole and go. So all of that I do before I get to residential. And in residential, there's a lot of applications within residential. It's still one of the biggest markets for helical piers. So you have retaining walls for residential, residential retaining walls or basement wall repair. You've got new construction, a lot of custom lake homes and sites that just have poor soil conditions that are otherwise unbuildable. You can utilize the helical pier. They're great for that. Then you have foundation repair. That's a massive industry. Nearly 50% of the homes in the U.S. have foundation settlement issues. So with this pier, I'll get into it more in detail, but you can install it next to the existing foundation, support it with an underpinning bracket, and then now permanently support and even lift that structure back to height. And finally, we have decks and other auxiliary structures like cabins and sheds. So the great aspect of this is if you're up north and you deal with frost heave, you won't have that issue with a helical pier. You can install it well below the seasonal frost layer and keep that deck where it's at. Also the speed. So you can install a 4-pier deck in less than 2 hours, start installing it, and be out of there the same day. Okay, there's no other product you could do that with. All right, so now I want to play a couple videos on specific applications that we believe there's a lot of different markets specifically for them. So this first one I want to show is our tieback. This is a sheet pile wall, but there are a lot of other types of retaining wall structures that you can also use the helical pier for.
The tieback process begins by driving the sheet piling. The piles are vibrated into the ground using a hydraulic hammer. After the sheet piles are installed, the soil can be excavated. Next, the PureTech helical tiebacks are turned into the soil. The torque is carefully monitored throughout the entire installation procedure. Once the tiebacks are installed, the threaded adapters are bolted into position. Then, the I-beam whalers are installed over the threaded adapters and bolted in place. When construction is complete, the PureTech helical tiebacks can be removed and reused on the next project.
All right, so that's our video on tiebacks. I want to go over some of the key elements of a tieback installation. So as you can see, the material there was a solid square bar shaft material. So that's very typical for a tieback. And the reason for that is because a solid square bar only has friction on its corners during installation. So it requires less torque to put it into the same depth as compared to a round tube of the same diameter. Also, it has a much higher yield and tensile strength material. So the pull forces required for a tieback, it's suits itself very well for those applications. That's why we use a solid square bar for a tension or tieback application. Typically, you're going to see 3 to 6 helical bearing plates attached to the pile, and you may see them all on the lead section, or you may see some on the lead section and some on the first extension. That would be called, helixes on an extension would be called a flighted extension. But the reason you see so many is that the tiebacks generally do not get as deep into the ground to the better bearing material. So we need more helix area to then support that load capacity. Typical spacing for a retaining wall project is somewhere in the 4 to 6 foot range on center, and that's vertical and horizontal. And that would be for a 1.5 inch square tieback. Depending on the surcharge load of the soil behind the retaining wall and any hydrostatic pressure, that value may change. Also, depending on how much of the lateral force the sheeting or other retaining wall material is taking up. The most common bracket is for the tieback is called a thread rod adapter. Here's a picture of it right here below. As you can see, it's essentially an extension that is tapped in one end to receive a thread rod. So the common thread rod size for an 1.5 inch square is a 1.25 inch by 7 inch thread UNC. So the thread rod, you buy that in long lengths, and then you can cut it to whatever length you need and thread it right into this thread rod adapter. So remember that, that's the most common bracket for the tieback. That'll be on the quiz. It's called the thread rod adapter. All right, the next application video I have for you is called our Hercules pier. This is a high capacity helical pile that can be used to support multi-story buildings, large overturning moments that require for tower construction or pipe racking for the oil and gas industry. This pier is very design build specific. So the material is not stock finished. The raw goods are then cut to length and the helix is sized specifically for these individual projects. So enjoy this video.
Across the country and around the world, helical piering is making its mark as a permanent foundation solution for poor soil conditions. But until now, it has been limited to residential and light commercial applications. Now, all that has changed. PureTech Systems introduces the Hercules Pile. For over 30 years, PureTech Systems has been a leader in high-strength helical piers and anchors, providing the industry with the very finest in high tensile strength square and round shaft products. Now, they are revolutionizing the market with their patented high-strength, high-capacity Hercules Pile. This patented pile is available in both round and square shaft material. It can be galvanized and it boasts load capacities of up to 500 tons. Imagine being able to easily use helical piles for a 10-story building application. Think of the time and the money you'll save. And with no vibration, the Hercules Pile is successfully being installed in large cities where surrounding foundations are a concern. Additional advantages to the Hercules Pile are fast, hassle-free installation. It can be installed under any weather condition. Installation produces minimal noise. There is absolutely no vibration from the installation. The pile produces no overburden. And PureTech Systems provides site-verified loading. With shaft sizes ranging all the way up to 16 inches in diameter and load capacities of up to 500 tons. No job is too big.
So that was our Hercules pile, and the Hercules pile in that video was a 7-inch diameter pipe section. The project was installed to approximately 60 feet and was load tested to 400,000 pounds and saw about 3/8 inch deflection total at that load. So it performed very well. And that was for a 10-story building application.
PureTech Systems.
Some of the key features of the Hercules pile are shaft sizes ranging from 4.5-inch diameter to 24-inch diameter pipe sections. So here's some of the common pipe sizes that we offer. Here on the left side, you can see OAT by OD, 4.5-inch, wall thickness 337, with a crosslock or a welded version. Or a welded collar. You have about 24,000 foot-pounds of torque and get an ultimate load of 140,000. The K factor I'm going to explain in another section coming up. Then the 5.5, you get around 40,000 foot-pounds, close to 200,000 pounds of ultimate load. 7-inch 408, 299 foot-pounds of torque, 9 5/8, somewhere in the 400,000 pounds of ultimate load, and 12 3/4, just over 500,000. When we get into the Hercules pier, the capacity is or the torque limit and the ultimate capacity will depend on what wall thickness and what grade steel we can get. So these values are all based on about a 50 KSI minimum yield strength steel. Helix sizes for the Hercules pier will range from 12 inches in outside diameter of helix to up to 40 inches in outside diameter, and could be up to an inch to an inch and a quarter thick. Wall thicknesses will also vary, and so will the grades of the steel, as I mentioned before, and they'll vary to meet the project demand. Also, what pipe is available in the market at the time. From a torque standpoint, we have drive heads that range from 30,000 foot-pounds of torque to 350,000 foot-pounds of torque. So you want to make sure when you're looking at a Hercules drive head that you look at a drive head that's sized for the range of pier you're putting in. So if you're putting in a 4.5-inch pier, you may look at a 30,000 foot-pound drive head. If you're looking at a 7-inch pier, you may look for a 100,000 foot-pound drive head, as seen in that video there. Or if you get up to the 12 3/4, maybe you end up purchasing one of our 350,000 foot-pound drive heads. So the right side, you can see the drive head hooked up on an excavator. We can make a mounting custom mount for your excavator to fit these bigger drives. All right, the next application video I want to share is our boardwalk video. This project was one of the largest pedestrian boardwalks in North America at the time, with over 1,000 feet installed. And part of this boardwalk was path and part was over water on H-pile, and then part of it was over land on helical piers. So here you go. So that was our boardwalk video, and so there's a lot of key elements to a timber walkway or timber frame construction type project. So here's a typical detail you may see on a plan spec. So you'll see at every bent there will be typically 2 piles. That project in that was a very large, wide boardwalk, wider than typical, and would carry vehicle traffic. So there was 4 piers per bent in that on that specific project. This one you see 2 piers per bent. The framing and everything will be called out by the engineer, and then the piles will be, every bent will be spaced between 8 and 12 feet apart. And then if the load increases or the elevation increases, you'll see a battered pier put in for bracing. So this pier at an angle that you see down here is in place to keep the swaying, the back and forth swaying from happening because of how high this decking is out of ground. We've also done some X bracing before, where we go through and hook steel between the piles after they're installed. That's another method of bracing. Saddle brackets, these top bracket portions are available in all sorts of different dimensional and rough sawn beam sizes. So we'll custom make that depending on what the project requires. So here's a little picture of a saddle bracket. Typically they bolt with two bolts across through the timber, and then the pier bolts on to the top of the pile cap. So you'll usually see the piles be driven and then cut off to the exact elevation, because it's very difficult to necessarily drive to that close of a tolerance for this. So you'll see the piles cut off and either be re-drilled and bolted or welded to the piles. So here's a picture of that project. Again, you can see the piles, the typical spacing you see, and that the piles are attached there on the bent. All right, the next video we've got is our deck footings, and these are specifically for fixed decks that are attached to residential structures, like commercial structures.
Hello, I'm Michael Wilkes, an engineer with PureTech Systems, and I have a new product to share with you. The PureTech Helical Deck Pier system will allow you to install a deck foundation in hours instead of days. The system works by combining a proven helical pier technology and an easy-to-work-with post-bracket assembly. This fast, hassle-free installation requires no concrete or welding, and when the piles are installed beyond the frost zone, the foundation is not susceptible to frost heave. Difficult to access spaces are not an issue, because this product can be installed with small equipment and never again worry about hitting the precise location, because the deck bracket is fully adjustable. Tools needed for this project are a PureTech helical drive head, cutoff saw, adjustable wrench, mallet or hammer, cordless drill, and level. The process of installing the PureTech helical deck pier and post bracket system starts with installing the 2 7/8 helical pier to the specified load. This can be done with a small mini skid steer equipped with a PureTech drive head. This high torque drive head can install a 5-foot deck pier in less than 2 minutes. Once the pile is driven to the proper elevation, the deck bracket installation can begin. First, insert the 1/2-inch bolt onto the top of the pier and lock it into place with a 3/4-inch bolt. Snug tighten the 3/4-inch bolt, then place the 6-inch square base plate, saddle bracket, and 2-inch square washer onto the 1/2-inch eye bolt, and then tighten the assembly with a 1/2-inch nut. There may be excess bolt threading. Trim that right off. Once the excess threading has been trimmed flush, slightly loosen the nut to allow for bracket adjustment. Then place the 1-inch standoff plate on the saddle. Place the deck post into the saddle. Adjust the post to plumb using a level and mallet. Secure the post on all 3 sides with the required screws. Once the post is perfectly plumb, tighten the 1/2-inch nut through the hole in the standoff plate. To complete the installation, with a pair of pliers, pull the open side flush to the post and secure with 3 screws. Finally, place dirt around the exposed pier for a nice, clean finish. The PureTech helical deck pier and post bracket system is a cost-effective alternative to a traditional concrete foundation. So if you'd like to save time and money on your next deck project, choose PureTech Systems.
All
right, so here's some key elements to our deck post piles. So they're fully adjustable from north, south, east, and west. So you could be off by 1 inch to 1.5 inches and still have that bracket function for you. So that would be this direction here on this detail. So here's a detail of the deck post in place. You can see that the pile's installed and left about 4 or 5 inches above grade, and then attached to this 6x6 with the adjustable deck post bracket. We've got this bracket available in both 4x4 and 6x6 dimensional lumber. We can get other size brackets at request, but those would be custom made and custom ordered product. The common pile shaft diameter for the deck pile is a 2 7/8 OD. We do offer different sizes as well if the project requires it, but as that is the most common and readily available residential product, that's what we use mostly for it. Common length of installation for a deck pile north of a 36-inch frost depth is a 7-foot deck pier. And the reason for that is to make sure that your helix is embedded well below the frost zone. That's critical to make sure that you don't have heaving of the deck over time. So a 7-foot single helix pile will carry anywhere from 1,000 pounds to 5,000 pounds depending on the soil type and the helix diameter. Typical helix diameters are 8-inch, 10-inch, or 12-inch, and we have a load chart available for selecting what size to use depending on what soil conditions and loads you're looking for. All right, the next video I've got for you is our new construction residential. We're going to play this video, and then right after that we'll have a new construction commercial project. There's a lot of great new construction applications that you can attack with this product. So that project was a 2-story full basement project with approximately 50 piers. And the reason why it was used helical piers, it was the last lot in the subdivision, and the soils were poor, so they could not over excavate and bring in fill material. So that's the reason that they end up going with piers in that lot. Next video I have for you is the commercial new construction application. This is a project that is using helical piers to support a golf course. So let's watch this video.
For many years, PureTech Systems has provided high-quality helical pile products to commercial new construction markets. PureTech is revolutionizing the commercial industry with its patented cross-lock connection. This connection is now allowing contractors to complete pile installations in days instead of weeks. The process begins by excavating out the footing, grade beam, and pile cap locations. Once excavated, a surveyor will mark out the precise location of each pier. A load test can now be performed to verify the site load bearing capacity of the helical pile. PureTech recommends following ASTM quick test methods for either tension or compression. For a tension test, the test anchor is installed to the design depth and torque. Once reached, a threaded bar adapter is bolted to the top of the helical anchor. Dunnage, or reaction beams, are then placed next to the test anchor, as specified by the helical anchor design engineer. A threaded rod is used to secure the helical anchor to a test beam. A hollow ram cylinder is added above the test beam. Reference beams, made of angle iron, are placed next to the ram. The reference beams will hold multiple dial indicators, which will be used to measure deflection during the test. An ASTM tension test involves adding incremental load to a test helical anchor. The load is held at each increment, and the dial indicator measurements are taken. The maximum applied load during the test is typically 200% of the design load. Once the test is completed and approved by the project engineer, the helical anchors can now be installed. A skid steer equipped with forks is utilized to move pallet loads of helical leads and extensions to the site. Each section is then carried into position to speed up the pile installation process. PureTech's telescopic skid steer attachment brings great versatility to the job site. Its universal skid steer mounting plate allows the installer to use a wide range of skid steer models. During the installation, torque is continuously monitored with either an inline pressure relief system or the Real Torque TrueLink monitor. The TrueLink monitoring system will log all of the data throughout the installation, and it can be emailed directly to the design engineer at the end of each day. The certified PureTech installer will maintain a consistent installation by adjusting down pressure and drive head speed. PureTech's RS-12 commercial drive head has the ability to torque a pile to 13,000 pounds, which is a load capacity of nearly 100 KIPS, which is a load capacity of nearly 100 kips. The patented cross-lock connection hooks together quicker than any other round shaft connection in the industry, saving critical days in the production schedule. Once the piles reach the design capacity, a new construction cap is placed on top of the pile and bolted into place. After the rebar is placed and the forms are erected, concrete is poured over the pile caps, locking them into place. Whether you're a commercial developer looking to build a new office building or warehouse, or a general contractor looking for a cost-effective alternative foundation system, PureTech Systems will be with you through the process from start to finish. PureTech Systems, driven by innovation.
All right, so some key elements to the new construction piles include piles can be installed under load-bearing walls and column loads. So on the right side of the screen, you'll see some details. There's a garage footing detail for a new construction with a turn-down frost slab, insulated frost slab. Piles are embedded up into that prior to it being poured. Here is a frost wall footing with a interior slab, and the piles are embedded again within a footing itself. Even if you do a frost wall that's maybe 8 or 10 inches, I typically still
like the design of having a wider footing, maybe 18 inches at minimum, so that you've got the adjustment within that footing to be off location. So it's built into it a little bit better. Also, you can put the pile underneath the column load. So for light residential loads, you could place the pile directly under the column. Once you get up to higher column loads and commercial loads, it's required to put 3 piles at minimum underneath the column load for stability purposes. You can also run grade beams and different things between those pile caps to limit the amount of piles underneath a column. Grade beams, pier caps, again, are formed around the piles themselves, and then new construction caps are placed after the piles have been cut off to elevation or driven to elevation, and they're placed on top. They look like the picture here at the bottom. They have an outer sleeve coupling that sleeves over the pile and bolts to it, and then a top plate that's pre-welded that's sized according to the load capacity. The typical embedment depth of that bracket is 3 to 6 inches from the bottom of the footing excavation. Very important, that's going to be on the first quiz. So approximately 3 to 6 inches between from the bottom of the footing excavation is where this top plate cap should rest. Tolerance ranges from northeast southwest. Dimension are typically in the 1.5 to 3 inch range, depending on how much room you've built into the design of the wall or the footing that it's being placed in. Next application video, the last one I've got for you, is residential repair. Watch this video again and then talk about some key elements to foundation repair.
Every year, millions of families suffer from cracks in walls, cracks in ceilings, doors and windows that stick or won't close at all, and damage to siding, brick, and concrete. This is all due to shifting foundations. PureTech Systems has your permanent foundation solution. The process begins when a PureTech certified installer performs a site survey. The installer will mark the building, electrical and gas lines, and the location for each pier. Then the excavation process begins. Either by hand or by machine, holes are dug in the location for each pier. This reveals the footing and allows for proper bracket placement. Once the holes are excavated to proper depth, the footing must be notched to create a flat and smooth surface for mounting the bracket. Using a bobcat, the helical piles can now be installed. The technician continually monitors pressure and torque. PureTech's patented cross-bolt connection eliminates all unwanted movement in the piles. Once the pile reaches design depth in load-bearing strata, the pile is cut off at the proper height. The PureTech TrueLift bracket is then installed backwards and rotated under the foundation. The TrueLift bracket has been patented to draw into the foundation, providing a more reliable and stable permanent solution. Once all piles have been driven and all brackets installed, they are locked down and the house can now be raised. Using a hydraulic jack, each pile assembly is raised into the foundation. This careful process brings the home back to level. It loosens doors and windows, and in many cases, it closes cracks. Once the foundation is successfully stabilized, all holes are backfilled, and every effort is made to return the landscape to its original condition. PureTech Systems, your permanent foundation solution.
All right, some key elements to foundation repair. The helical underpinning piers are typically installed next to the foundation to support the structure into a load-bearing soil or bedrock layer. So it doesn't necessarily have to rest on bedrock. It's going to torque out in a load-bearing strata. Piles are typically spaced every 4 to 6 feet apart. So you can see the measurement here from the top picture, every 4 to 6 feet. And then are spaced at every 2.5 feet off the corners. So here where the excavation, every 2.5 feet. The foundation is excavated at each location where each pile is going to be placed, like in the bottom picture, or along the length of the repair, like in the top picture. It's important that if you do excavate the full length, that you do not undermine the footing the full length. You do not want to keep that, you do not want to over excavate underneath, or else you're going to have problems during installation where that footing is going to settle and move on you. The footing is notched to the foundation wall, so that means you need to cut it back all the way until you get flush with the foundation wall. And then across, about a foot across, but for the width of that cut. Piles are installed typically at a 3° to 5° angle from plumb towards the foundation. And it's typically best to use a single lead. So just one helix on the lead section so that you can put that pile down and socket it under the foundation. And then you can see that slight 3°, 5° batter with the drive head there against the foundation. The install load can be achieved by multiplying the load per linear foot along the foundation by the pile spacing and then doubling that result. That'll give you how much install load or ultimate resistance that pile needs to have. So an example, you have a 2,000 pound per linear foot load at a 5-foot spacing. So you take the install load and you install load, and that equals the load per linear foot as 2,000 pounds times the spacing, 5 feet, times your safety factor of 2. So that gives you an ultimate load requirement of 20,000 foot-pound, or 20,000 pounds. So this means the minimum install torque is somewhere roughly 2,300 foot-pounds, and we'll cover that in a later section on how you get to that 2,300 foot-pound value. But that's a rough for that 2,000 pound per linear foot at a 5-foot spacing. So once the pile is driven to its torque requirement, it can be cut off. And it has to be cut off typically 10 to 16 inches above the bottom of the footing, depending on how much lift you want to achieve. So the true lift bracket can then be assembled per the installation instructions. So here's a video of that right now. As you can see, they take the bracket, install it on, rotate it backwards underneath the foundation. And with that thread rod, they'll put the T-bar, also known as the slider, into the pile through the thread rod, and then put a couple nuts and washers on the top to secure and lock the whole assembly together. Again, you can see that is a couple inches away from the foundation, but as you lift and put load on that bracket's going to want to suck in towards the foundation as it's being lifted. So now he's going to put on the jacking block on the top, and he's just using a slider that's upside down, the T-bar upside down. You put the jack in there and then tighten the nuts and washers. Once all that assembly's been tightened, you can attach the bottle jack and you're ready to lift. So once all the piers and brackets are installed,
the house can be raised using a 20-ton bottle jack or a hydraulic manifold system. So here's a short little video here received from one of my customers. As you can see, they're slowly working down the foundation wall. He's got a guy on the inside, and he's out here on the outside, and they're slowly working their way down as they're lifting and adding load onto each pier. So they're slowly adding load, and that load is causing the foundation to raise back up to close to its original elevation as possible. So he'll continue to walk down the line, giving a couple pushes on each bottle jack as he goes through. Again, after you do each push, make sure you tighten the nuts at the top of the slider, so that if you do lose your lift, you still have that tightened up there with your slider. All right, so next we have foundation advantages. With the helical pier, the installation equipment is very maneuverable. So you can see up here at the top we have a walk behind, installing a helical pier through a forest for a boardwalk. Very maneuverable equipment. You can install in limited access areas, like this oil refinery or gas refinery here. The drive head is installing a Hercules pier over an existing gas line and underneath an existing power line. You couldn't do that with many other foundation types. Installation is unaffected by caving soils or groundwater, so you don't have to worry about casing a hole or dewatering a site. And the installation produces very minimal spoils, virtually no vibration or noise. So you can install next to existing buildings or other foundations and not be concerned with risk of causing damage. They also install much faster than other foundation types. We talked earlier that you can go into the ground at about 3 inches per revolution, with a typical speed of install at about 10 RPM, 10 revolutions per minute. That means you're going in the ground 30 inches per minute or 2 feet every 2 minutes. It's going to take you longer to connect the pile sections than it is to install a 5-foot section in the ground. You can also build on the pile immediately. Up in this picture, you can see that the pile is being welded on here. This equipment is being welded directly to the helical pile. Also, you can verify the installation through torque. Torque verification is a big advantage of the helical pier. You can also put them in at an angle or at a batter for increased lateral strength, like the tieback application. You can transport them to remote sites with very limited equipment. And they can be removed for temporary applications like tilt-up. All right, that's the end of our section 1. I hope you guys got a lot of great information. Go ahead and click back on the Zoom link to join the Q&A session that will be starting very shortly. And again, make sure you have all those questions written down and ready for that. And then right after that Q&A section, we'll open up the time for the first quiz. Thank you guys very much. All right, welcome back, everyone. Hope you took some good notes during the first video section. We are going to start the Q&A here at the bottom of the screen. Go ahead and open up that chat feature, and you'll be able to text your questions in to Nick, and he will then pass it along to me, and I'll go ahead and answer those questions. Again, feel free to ask any questions you have on the first video section now. So if you have questions, again, go to the bottom of your screen, click on the chat icon at the bottom, open it up, and then type your question to Nick Pieper or myself, and I'll start answering those questions in order. We'll have this Q&A open to up to 15 minutes, depending on how many questions we get, and then we'll share the first quiz and the second video once all the questions have been answered. All right, have a question in from Mike. He said, for a residential foundation repair, do you need to pour back the notched section of the footing? And then what about the void that can be created underneath the footing after raising the foundation? So that's a good question. So that notch section, you do not need to fill in that notch section. The foundation itself is acting as a beam at that point to beam between pier locations. From a spacing standpoint, your spacing is going to be anywhere between maybe 3 to 6 or 7 feet, depending on how strong that beam is. If you don't have reinforcement within it, you want to lower your spacing, keep it closer together because it won't have that beaming capability. With any void that's creating under the footing, again, the foundation is now acting as a beam, so it goes between pile location and is no longer acting directly on the soil for support. So you can loosely backfill that area, or if there's a slab underneath and it creates a void on a slab that's not supported by the footing, then you would need to put a flowable backfill in there, either mud jacking material or a polyfoam, something like that. Next question is, can you use a more powerful drive head for smaller piers, and do we need multiple drive heads? So that's a good question. The drive heads will range in size from 5,000 foot-pounds of torque up to 350,000 foot-pounds of torque. A good rule of thumb I like to use is whatever your torque capacity is, you can, of a certain pier, if you double that capacity of that pier, that's probably about the maximum drive head that you want to use on that pier. So a 2 7/8 is capable of around 8,000, 9,000 foot-pounds of torque. You would then want to maybe use up to a 16,000 foot-pound drive head at most with that pier. If you use too large of a drive head or too large of a machine, you're going to risk breaking piles or creating too much down pressure during installation, which could give you, false torque readings. So you want your machine and equipment to be similar in size to the pier that you're putting in. Most of you are probably going to be in that 2 7/8, 3.5 inch pier range, maybe some square bar anchors as well. So a drive head that ranges between 8,000 and 12,000 foot-pounds is going to cover the majority of your installations. You may also need to have a handheld drive head if you plan on doing limited access installations as well. Next question is, question about drainage of water going into the void. You certainly do want to put a drainage system at the bottom of the footing to wick that water away, because that water can collect around the pier, and over time, depending on the soil conditions, could filter down the pier if you do not have proper drainage. So you always want to make sure you're taking care of the drainage if it doesn't already exist at that property. If driving a pier into the ground and you are 3/4 into the job being completed and hit a large tabletop size rock, and the pier starts to auger instead of thread. So that's a good question, Scott. If you are into the job and you hit a very large rock, there's a few things you can do. You can go ahead and remove that pile and relocate it along the foundation. You can move it one side of the rock and install another pier on the other side of the rock to bridge that obstruction. And depending on the size of the rock and acceptance by the engineer, you may be able to defactor the load rating of that pier and adjust another pier closer to it to account for that load capacity. So there's several different approaches you can take there. If you ever do run into that situation, give us a call and give your engineer a call, and we'll walk through some different options for you. Jason asked, what's the minimum install distance for piers for higher load bearing capacity or poor soil conditions? So minimum pier spacing is recommended at 3 times the largest helix diameter from center of pile to center of pile. If you have a 12-inch as your largest blade size, then the next pier over would be a minimum of 3 feet to the center of pile. I know a lot of engineers that recommend a 4 times spacing as well. So that 3 to 4 times spacing is where you want to be. If you're any closer to that, then you may want to put some batter on the piers to get them an angle on the piers slightly, so that the helixes are at least that distance apart down deep into the soil. And that way there's no group effect. They're not sharing the same soil, and you're getting a decrease in your capacity that way. Kathy asked, what is the level of corrosion protection in salt water tidal zones and resistance to abrasion during installation? So we certainly recommend galvanizing the pile in your saltwater tidal zone applications, potentially using an epoxy coating on the pier, or in combination with casing that pier with a grout, a concrete grout or column in that tidal zone area. So that will greatly lower your corrosion rate on the pier. The actual galvanization is very resistant to abrasion, and the galvanizing material that does come off during installation gets left in the soil, and it actually helps with the corrosion process. So, but again, if you're in a tidal saltwater zone, you'll want to protect that pile down through that tidal zone. So have maybe a little bit of an over auger with the material, and grout around that pile, put a sonotube down, concrete around the pile to protect that in that tidal zone. Additional questions? I'm going to leave this Q&A open for just a couple more minutes here before we share the next quiz and video. We got a question, what is the expected lifespan of a pile? So I'm going to talk about this a little bit more, I think, in the third video section, but the typical lifespan of an average pile or average soil condition for a for a helical pile is around 50 years for a bare steel pile. Adding galvanization on average adds 25 years to that life. So a galvanized pile expected lifespan is 75 years on average. And depending on the soil condition and how much load you want to use out of that pile, that will adjust your lifespan up or down. So if you expect the soil to be highly corrosive, which we're going to talk a little bit more about in the third video, then you'll want to do some additional corrosion protection, or make sure you're limiting the load capacity on that pier to help increase that lifespan. Great questions, everyone. Saltwater applications, mixed epoxy, what type? So you want to use a marine grade epoxy. We do not provide that. You want to work with a marine contractor or marine supply company and to get that epoxy specification. We ourselves don't specify that, or work with your local engineer on that as well. So Tony asks for highly active permafrost or ice wedge soils at the upper level. Do we have a plastic or slippery outer sleeve to lessen pier jacking? So the plastic sleeve, we've got a competitor up in Canada that uses a plastic sleeve around their pier. If you install the pier beyond the active heave zone of the soil, then the helix will provide enough support to prevent that pile from jacking up. So that sleeve is really more of a marketing scheme than anything. You've got a fairly small diameter pier that has a limited amount of friction on it, and the key is making sure that helix is embedded 3 to 5 times the diameter below the active layer to prevent that heaving of the pile. So if you're 3 foot frost level, you'd make sure that pier was down 6 feet at least in the ground to prevent heaving. The other key element to heaving is making sure that you've got good drainage, good sloping away from the piers, so that water doesn't collect. Again, if water's collecting around that pier and goes deeper into the soil, your frost will extend deeper into the soil and potentially get underneath the helix to cause it to heave. Scott asks, is it possible to pull piles after 15 years? It certainly is possible. The initial amount of torque required to release the pile can be pretty extensive. So you want to make sure you have a drive head capable of putting out enough torque to jar that pile free. All that soil is reconsolidated around the pier in that 15-year time span. So it could be a pretty significant amount of torque to jar that loose. Somebody says, what is the height of an exposed pier? We are repairing a foundation with 5 feet settlement from a bottom retaining wall. Typically, we recommend, if you're exposing a pier, that if you're exposing beyond maybe a foot or two, that you put in a horizontal tie back to attach to that pier, and that will brace the pier. The design of the foundation repair pile, if you're looking at the pier like this with the L bracket sitting under the footing, the load comes down and this transfers into the pier, and that bending force is pushed into the soil. So if the soil is gone out of that, you increase your bending force quite a bit, and you could have a localized buckling issue. So if you do excavate beyond maybe more than a foot or so beyond the pier, we recommend putting a horizontal tieback in to resist that bending force. All right, so that's going to end the first Q&A session. If you have more questions, write them down. I'll get to those in the next Q&A session here. I'm going to go ahead and have Nick share the first quiz and the second video section now in the group chat. Make sure you copy and paste the quiz into your browser, and also copy and paste the video into your browser before you exit the class. Okay, that's really key. So you don't have to come back in here to get it, and you've got it and are able to do both. Make sure you're able to open up both before you leave the class. You can either do the quiz now, or you can watch the video first and then do the quiz. However you want to do it, that's okay. We just want to make sure you have all the quizzes completed by the end of the day. So once you're finished with everything, if you want to do the quizzes, then that's okay as well. Let me see how long the next video is. I think it's, give me 1 second. So the next video is about 45 minutes long. We're going to go ahead and say we'll have you come back here at about 12, let's call it 12:15 Central Time, 12:15 Central Time, to start the second Q&A session. All right, and for those, welcome to section 2 questions. Go ahead and save those questions for the next Q&A session. I'm gonna have Nick share the quiz in the second video again. Once you see those, copy and paste them into your web browser. Make sure you're able to open both. If you want to save that quiz on a Word document or somewhere on your desktop so that you can access it later, make sure you do that. Once you've confirmed you're able to open up both, go ahead and leave the Zoom link so we know who has successfully completed it. And then make sure you join us back here at 12:15 time frame. That's 12:15 Central Time.
2 of our helical pier training and certification class. This section will cover equipment and installation. Again, make sure you take good notes for our Q&A session and the quiz. I'll make sure to point out Welcome to section 2 of our helical pier training and certification class. This section will cover equipment and installation. Again, make sure you take good notes for our Q&A session and the quiz. I'll make sure to point out specifically where the questions on the quiz are going to pop up. All right, installation equipment. So there are several key components to a helical pier equipment package. Elements you're going to want to make sure you pay attention when you get set up. So first you have the drive head. The drive head is pictured right here. That'll vary in torque capacity, length, size, weight. All of those features come into play with the drive head. Then you have the mount. The mount unit, this is for a skid steer, but it'll mount the prime mover machine, whether it be a skid steer, excavator, backhoe. It'll mount it to the drive head. Next you have the link arm piece. This connects the drive head to the mount. Then you have the Kelly box adapter to attach the drive shaft to whatever pile tooling you plan on using, the drive tool. And that drive tool will be sized depending on the pile size and diameter that you're installing. Next you have the torque monitor. The torque monitor can either be a couple pressure gauges that are plumbed in line with the hydraulic system, or a real torque monitoring system that's attached to the drive head itself. And then last, you have hydraulic hoses. Those may be something we supply for a standard package like a skid steer that has a universal length, or you may custom fabricate it for your excavator, depending on where you want to hook your gauges and your system. All right, let's dive into the hydraulic drive head. So our hydraulic drive head is different than your traditional auger motor that you may get at a rental shop. One of the main differences to the drive head is it has a high torque, low speed gear ratio and hydraulic motor setup. So it's geared to run at a much lower speed than a typical auger, which runs at 40 RPM plus, 40 plus, maybe up to 60 RPM. Torque-wise, it'll also go to much higher torques than most standard augers that run at 2,000 to 3,000 foot-pounds maximum torque output. So the machine mounted, we have skid steer. You could attach to a skid steer pictured here in the left side, or potentially a backhoe or excavator as pictured here in this first top left picture. Drive heads, we have drive heads in the range from 5,000 foot-pounds to over 300,000 foot-pounds. And you're going to size your drive head based off of the applications you plan on installing, along with the size equipment that you have to hook it to. And then it's very key, remember to write this down, that you want to be installing at a speed between 5 RPM to 25 RPM. And it's really critical never to go over 25 RPM, because you will not get accurate torque readings, and you potentially will have issues with pile damage during installation. So the good range, or the range that you want to stay within, is 5 to 25 RPM, and the kind of the set RPM speed that you want at final torque is somewhere in that 10 RPM range. Next, you've got the hand. So I want to get into specifically some drive heads that we offer, some of our main drive heads for the smaller diameter helical piles. The first model we have is the RS6, and this is considered our handheld drive head. So you can get this in two methods, one with the bale housing as pictured up here in the right corner, or without the bale housing for the handheld. And you can adapt it to go handheld or machine mounted by removing this outer bale housing. The max torque range of this handheld drive is 6,750 foot-pounds at 2,500 psi pressure. It's key that you check what max pressure your machine's auxiliary hydraulics can get to, so that you know what max torque output you can get to.
The other important thing to note is that this can be mounted to a handheld, a walk-behind, small skid steer, or up to a 3.5-ton excavator. And we recommend a minimum flow rate of 10 gallons per minute. That's really critical. Remember, 10 gallons per minute is the minimum flow we recommend. That'll be on the quiz for the handheld drive. So here's the setup down here in the bottom left-hand corner, the drive head, yoke, and torque bar, and then the hydraulic hoses are ran to a foot pedal that used to operate the hydraulic flow. Minimum required pressure is 2,700 psi for this drive head to get its full maximum output. You're going to find out later that every drive system is going to have some back pressure to it that you have to subtract out of this to get your overall chart pressure here. The maximum pile capacity expected from this drive is somewhere in the 50 kip range. So you could get about 50 kips maximum from the RS6 drive. Next we go up to our model MM10K, which is an 8,000 foot-pound drive head. This drive head can be mounted to a mini skid steer attachment or to a full skid steer or excavator. It has a maximum torque rating of 8,300 foot-pounds at 3,000 psi. Has a minimum recommended flow of 10 gallons per minute and a minimum pressure of 3,200 psi. So this unit's very, very cool and versatile. You can hook it to a mini excavator and then hook the same equipment to a walk-behind skid steer. And it's unique in the fact that it also connects to the side of the drive head, so you eliminate some of the overhead of the dangle style mount that I'm going to show here in just a little bit. Maximum pile load of this drive head is around 65 kips if you absolutely max out the pressure. Next we have the Model 12 DLS. This is a 10,000 foot-pound drive head, and you can get this in either the side-mounted version as shown up here in the right picture, or as in the bottom left-hand picture, a dangle style where it hangs from above the drive head. This model will max out torque-wise at around 9,900 foot-pounds at 3,000 psi. So the machine will hook to a skid steer or up to a 9-ton excavator, and we recommend a minimum flow in the 15 gallons per minute range and a minimum pressure around 3,200 psi. Again, that's in the auxiliary circuit of your machine. So make sure you contact your dealer and ask them that question. Next, the maximum pile ultimate load capacity is 75 kips on this drive head. You absolutely max out the pressure. The next step up from there for our small size piles is our DH12 model that puts out 12,000 foot-pounds of torque at around 3,000 psi. So in that 12,500 foot-pounds at 3,000 psi. This drive head's a little bit longer and a little bit heavier than the 12 DLS model, which is a 10,000 foot-pound drive. And it can be hooked to full-size skid steers or up to a recommended 12-ton excavator. And we really recommend minimum flow of around 17 gallons per minute, which gets you, if you look over here on the flow chart, around 10 RPM at 17 GPM. I like to go at about the 10 RPM range to determine what the min flow rate needs to be to operate the drive effectively. Again, the same minimum pressure requirement, somewhere in the 3,300 psi range. And this drive head will install a pile up to 90 kips, so around 90,000 pounds ultimate load.
So that wraps up our small drive heads. We offer a large range of bigger drive heads. If you're interested in those models, please contact us for the machine specs and we can get those to you. All right, so the other important thing is the attachment, so the mount from attaching the drive head to the machine itself. We can custom fabricate a mount to fit your excavator, or we can you can make a mount potentially for yourself, or we've got the handheld yoke and torque bar mounts as well. The key element when you're coming up with a mounting system is that the drive head is free to swing either forward and back or left and right. And that's critical to make sure that the pile will hang plumb when you're on uneven ground. Also to make sure you're not putting a side load into the pile, into the drive head. That's going to either potentially cause you to fail piles, break piles, or cause your drive head to wear out much sooner than it should. All right, now we got a short little video on our telescopic skid steer attachment. This is a universal attachment for most skid steer models and is our most popular unit.
The PureTech telescopic skid steer attachment delivers strength, versatility, and precision. This quick attach system mounts and secures within seconds. With multiple locking positions, the arm allows for up to 6 foot of reach and will install up to 10-foot pile sections. The telescopic attachment also comes with a mounting plate for the inline torque monitoring system and features easy setup, adjustment, and viewing. With the ability to handle up to 20,000 foot-pounds of torque, this attachment is suitable for both residential and commercial drive units. The link arm swivel allows the drive head to remain plumb, even when the ground is not level. So for your next project, choose the PureTech telescopic skid steer attachment.
All right, so that attachment again will give you some good versatility. The good thing about a skid steer is it has a higher pressure and flow than a typical excavator of its similar weight class would, because it's made to run attachments, so it's got much better auxiliary hydraulic output. So a lot of people will choose a skid steer for that reason. The next attachment I want to show you is specifically our mini skid steer attachment, which is very versatile for deck pier type installations. Again, this is a side mounted style drive head.
The PureTech mini skid steer attachment works with most walk-behind models, such as the Dingo, Vermeer, or Bobcat. This attachment includes a gimbal-style mount for low headroom areas, an 8,000 foot-pound drive head, 2 gauges, and 2 short hoses with quick disconnects. Our innovative mini skid steer attachment will allow a 5-foot helical pile to be installed with just 1 man in less than 2 minutes. On your next limited access project, choose the PureTech Systems mini skid steer attachment.
All right, so those are the main attachment size we make. Again, we can custom fabricate an excavator mount to hook up to whatever type of excavator you may have as well. Next, I want to show torque monitoring. So the first basic torque monitoring method we have are called the inline pressure relief assembly. Again, this is going to be on the quiz, the inline pressure relief assembly. This has 2 gauges, a forward gauge and a back gauge. So during install, you're going to monitor and watch each gauge and write down the pressures as you go into the ground. So that torque with this method is being measured indirectly. It's based on the gear ratio and the motor displacement. That is how you come up with the pressure to torque ratio. This is very drive head specific. So every drive head is going to have a different pressure to torque chart. So make sure you get the pressure to torque chart for the drive head that you end up purchasing. Next, when you are monitoring with an inline pressure relief, you have to subtract the back pressure from the forward pressure to take out all the inefficiencies of your hydraulic system. This is very important. So example would be if you had 2,000 psi on the forward pressure gauge
and 300 psi on the back pressure gauge, your differential or pressure drop would be 1700. So that would be your gauge or your chart pressure. The one downside about this unit is it may require calibration. When you hook this up in your system, the effect of torque is going to depend on the hydraulic system as a whole. The length of hose, the size of hose, the type of fluid you have in there, the temperature, the outside temperature of the air, all of that will affect the pressure to torque relationship. Maybe very minutely, but it will affect it. So if you're doing commercial work, you may require this unit to be calibrated, and that requires somebody with a real torque monitor to come out to your equipment, hook it up, and install up here and log your pressures at the various torque readings. So it's a very costly thing if you have to get it calibrated. Next, we have the digital version of the inline pressure relief called the Digital Hydraulic Pressure Gauge Setup, or the PT Tracker. This unit measures torque indirectly as well, but it uses two pressure transducers to read the pressure and send it electronic signal to a wireless box and automatically convert it to a torque. So it is much more accurate because it doesn't rely on the eye and reading a gauge at a far distance. Torque is logged in real time and recorded, so you can print off a chart to provide an engineer for use at a later time. Also, you can print off a graph, so the graph also can be emailed or printed off for an engineer. Again, you're increasing your productivity because you don't have somebody out there having to watch the gauges and write it down with a manual log. Also, you're decreasing your chance for human error of seeing the wrong number on the gauge. It's a very common thing that can happen if you're not paying attention. So next we got our top of the line unit called the IntelliTorque. It is a real torque strain gauge monitor. Again, this is important. This will be on the quiz. The IntelliTorque is a real torque strain gauge monitor. This unit measures torque directly with a strain gauge. So you're reading actual true torque rather than a theoretical pressure to torque relationship. As you can see in the picture, this unit has two flanges that bolt between the Kelly box adapter and the drive tool. And all the monitoring is done in between this unit here, and a signal is sent electronically to a smart device, any smart device that you have, whether it be an iOS or an Android. You increase your accuracy for torque reading, so you're getting very accurate with your torque reading. That's a big benefit to this unit. It also comes with a calibration certificate. So for a commercial job, if you require a calibrated torque monitor, you can just simply supply that certificate that comes with the unit. And typically, most specs require the unit to be calibrated within the last year. If you need a unit calibrated in the future, you can send it back to us and we can get it recalibrated for you. There's an inclinometer built in that keeps a constant reading of installation angle. So this is a nice feature if you're trying to put a pile in at a certain angle and you want to get a good idea and a good feeling for that. That is a nice feature to have. Also, this will log the information and record it in real time. So you can create a nice chart like you see here on the right side. You've got the time, the depth of installation, and the torque readings that happened as you're going down. So very good information. This is a big selling point to engineers, and it's really a must-have for commercial work. All right, next we have the installation methods and procedures, and there's two things you really want before you get started with an installation. You want to have a pile log and a pile plan. All right, this is key. This is going to be on the quiz. These are the two most important things to have before you start the installation. Get a pile log
put together and a pile plan. So the pile log will contain a lot of critical information about the install. The pile plan will have the pier locations called out and numbered, and potentially some load information or other key notes about tolerances of installation for the piers themselves. So this is really critical to have both of these set, and then when you go to do the job and you're starting pier number 1, you can then record that information under the torque log for pier number 1. So here's a closer look up at the pile log. We can provide you Word document versions of this that you can modify and use for yourself, but it'll include information like project name, number, date of installation, contractor name, installation equipment used, torque measurement device, maybe the date of calibration as well, and then a lot of other information like number of helixes on the pile, pile diameter, helix diameter, and minimum required torque. And then most importantly, it has the torque readings with depth. And typically, you're going to take a reading approximately every 3 feet or less. And that way you have a full picture of the soil as you go down through the installation. And your final torque reading will be here at the bottom. And that's going to be you're going to make sure your final torque reading equals or exceeds your required minimum torque. So here's some general installation procedures I want to go through with you. So first you want to attach the helical pile to the lead section using the approved drive tool. So again, you want to make sure you got the proper drive tool for the pier, attach that with a drive pin. Then you lift that up and then center the pier over the planned pile location. So you want to make sure you get that nice and centered up. Once you have it centered, push the pilot bit into the soil until the bottom helix engages the ground surface. Before you start spinning, check for pile plumbness. So plumb up the pile before you start rotating. Also check for alignment and plumbness of the torque motor and linkage. If you've got a side load on it and your pier is plumb, what will happen is you'll start spinning it and it'll want to wobble around. So you want to make sure that's nice and aligned. Then you begin rotating while applying a slight down pressure. You don't want to be applying enough down pressure that you're lifting the tracks off the ground, but you want to be applying enough so that you can maintain advancement of the pile. And then you're going to continue installation and check plumbness as required. It's key to remember to make sure you record, your ground guy is recording your pressures with the selected depth interval, so that depth interval again usually is in the 3 feet, every 3 foot range. So if you want to take an extension and spray paint a line down the middle and at the couplings, that's usually where you're going to take your readings. Then make sure to stop at the ground surface. So once you get that first section down to the ground surface, stop so that your operator can see the drive pin hole. And then once he can see it, he can stop, let off the torque off the drive head so you don't have residual torque on that drive pin or the coupler. And then the ground guy can then pull the pin out and the operator can lift the drive head off. Then you'll want to add the extension section until you reach your desired torque and pressure. Continue to check plumbness as required. And this could be done with a level during installation or visually by having the ground person to the left or right of the operator, keeping track of the forward and back positioning while the operator keeps track of the left and right. Once you reach the specified depth and torque, stop your installation. Or if you can still have additional torque capacity available and you are allowed to install to a deeper depth, you could then continue to torque that pile until your coupling reaches the proper elevation. If not, you can cut that pile shaft to the elevation using a cutoff saw, portable bandsaw, and then
you may or may not have to re-drill the hole to attach a pier bracket cap, like a new construction cap. So once that's all done, you want to record the final depth, torque, pile elevation. All of that is important to log in your torque log. So I just want to show a brief video of that in action. You can watch this as it goes through here. So they start out by attaching the pier to the drive tool and lift it up into position. The pile is centered, and the round tubes are great because you can use a stake or a piece of rebar to center that pile up. Locate that pile. You can tell they're taking a lot of care and concentration in this aspect, as it's one of the most important is getting the pile where you want it to go to start and getting it nice and plumb. All right, once you get that plumb, you're going to rotate the pile into the ground, and now you can see how he's visually correcting plumbness for the operator. And then continue to add extensions until you meet your torque and your depth requirement. Bolts just need to be snug tightened. An impact wrench works great for that. Once you get to elevation, cut off the pile. Put on the brackets and attach the brackets, and you're done. So those are the basic procedures for installing a new construction helical pier. We talked earlier about the repair pier and the additional components of that bracket connection. All right, how do you know when to stop? Well, that's called termination criteria. And there's two important termination criteria for a helical pier. And these are both really important. Write these down. This will be part of the first quiz. Number one is final installation torque. That is the minimum required torque you have to achieve for that given pile. Secondly is minimum depth. That may or may not be required from the project depending on how much load and what the soil conditions are like. So some of the things that influence minimum depth are annual frost zones, unknown fill depths, soft soils, collapsible soils, expansive soils, or liquefiable soils. So those all can affect your minimum depth. So I want to go through a couple scenarios on whether or not you're able to hit one of these two termination criteria. What are some approved methods that you can do that are industry accepted? So the first would be, let's say you're not able to reach your minimum depth. Well, the first thing you could do is terminate the pile at the current depth. So first you'd have to contact us or the engineer and talk to them about the scenario. Say we are only able to reach a certain amount of torque at that depth, and we're not able to get any further because we've reached the torque capacity of our pile. So you want to make sure you get the engineer's approval prior to stopping that pile at the elevation. Second, you could remove the pile and modify the helix with a V-cut. So here's an example of the V-cut down here. You take the blade and with a cut-off saw, you cut it back at a 45-degree angle. That will help open up that blade for larger obstructions to fit through it and to relieve the friction on the front of that pile as it's biting into the soil, causing it to slice into the soil easier. Again, make sure you check with the engineer before doing this method. Next method would be remove the pile and install a smaller shaft or helix configuration. Well, if you don't have a smaller shaft available, that may not be a really great option, or if you don't have a smaller helix configuration available, that may not be a great option. But if let's say you're installing a double lead and you're torquing out and you just can't get to your minimum depth, you could potentially cut it off right here, and now you have a single lead. So you just have one single helix with your pilot 45-degree tip, and you can then go ahead and reinstall that. Or if you've got a triple helix, you could create a double by cutting it right here, and then create a double helix very easily. So those are another good methods if you were maxing your torque out before you're reaching your depth. So it's really critical that if a pile is removed and reinstalled in the same location, that top helix, it must terminate beyond the terminating depth of prior installation. So if you stopped your installation at 25 feet, you want to make sure this top helix is below that 25-foot level so that you know all your blades are in good virgin soil. Note, it's really important with any of these methods that you get the owner's approval or the owner's representative, being the engineer, approval prior to proceeding with the modification. Next, we have a scenario where your installation torque can't be reached. So let's say you go out to the job site and you've targeted a depth of 20 feet and an installation torque of 4,000 foot-pounds. So the first thing you do, you get out there and you install the pier, you're at 20 feet, and you only reached 3,000 foot-pounds. Method number one would be to add extensions onto the pile until you meet your torque and your depth. All right, if you continue to go and keep adding extensions but are not getting anywhere, stop what you're doing, give us a call. We'll help come up with some additional solutions, and give the engineer a call. You don't want to go out there and install a bunch of extra pipe that you don't need to. So before you just go and install the piers to that additional depth, give us a shout. So the next approved method is removing the pile and installing one with bigger plates. So if you can if you're installing a single helix and you've got some double helixes available, you can go and get double helixes to torque out, or maybe a triple helix to torque out into that soil. Next thing you could do is derate the pile capacity and add additional piles. So maybe a pile that was designed for 20,000 pounds is now good for 18,000, and you have to add in an additional pile into that wall load. Space the piles slightly closer together. Note, all of this is very important to get the review and acceptance of the owner. Other important thing I forgot to mention in the previous slide is, what if you hit an obstruction? So if you hit an obstruction, the great thing about a pier is you can back it back out. So you can rotate the pile back a couple turns and rotate it forward until you move that obstruction or are able to work your way around it. It's key not to over down pressure during this process, because you can cause the helix to cup and bend, and then it will no longer function as a helix. Usually a good indicator of this is if you suddenly drop torque and are no longer able to build torque, you may have bent a helix. Next topic I want to cover is installation safety. This is really critical. We've been fortunate through our 20 years to have no major installation safety issues or accidents. It's because we really find it's important to stress this to our certified installers that install our product. So the first thing, it's key, you want to have at minimum a 2-person crew, and optimal crew size is 3 people. So this is really important. Remember that. It's optimal crew size is 3 people. That'll be on the quiz. All right, also on the quiz, I forgot to mention that you want to make sure you write down the acceptable methods of if you cannot reach minimum torque or minimum depth. So if you didn't write those down, go back to those previous slides, watch those again, and write those down. For the 3-person crew, the first person is the operator. They're handling the pile installation procedure and keeping an eye on the safety of the crew. It's really important. Then they have the spotter. The spotter is taking the plumbness readings, the forward, back, right, left readings, and help directing the operator on plumbness and also on anything else they may see about the installation. Maybe the operator can't tell that his tracks are up and he's putting too much down pressure, so the spotter will point that out to correct him. Next, it's really important. Keep a clear communication between the operator and the spotter. So if you do have a 3 or 4-person crew, make sure you only have one person communicating with the operator. And next, it's good to have additional labor that can help move material around the site and help with the coupling and decoupling process. That sometimes can be handy to have an extra person for. So again, optimal crew size, 3 people, and make sure that you're always wearing hard hats, safety glasses, steel-toed boots, and eye protection. Very important. All right, now I want to get on to some of the different products we manufacture. So we manufacture both square shaft anchors and round shaft piers. So again, as I mentioned before, square shaft anchors are for tension applications, like guy wire anchors or tiebacks, anything with a pull force. So that's because they have very high tensile strength for the tension loads, and also they're easier to install on the ground due to the fact that they only generate friction on the corners of the shaft during installation. Next, you've got the round shaft piers. They're for compression applications, like underpinning a building or putting a building on a new construction building on a foundation. Round shafts lend themselves well to compression because of a term called section modulus. It's the fact that the tube itself will prevent, it is very good at preventing buckling scenarios. So for the square shaft anchor product, we have 2 different sizes, the 1.5" square shaft and the 1 3/4 square shaft. The 1.5" square shaft is the side-to-side length measurement, and it is a solid steel bar. It has an ultimate shaft rating of 80 kips or 80,000 pounds. Write these down, these are all important. And it has an ultimate torque rating of 7,000 foot-pounds. So an ultimate shaft capacity of 80 kips and an ultimate torque rating of 7,000 foot-pounds. Those will both be on the quiz. An 1 3/4" side-to-side dimension solid square bar has an ultimate shaft capacity of 100 kips and a torque rating of 10,000 foot-pounds. These are again both for tension applications. Then we go on to our round shaft piers. We manufacture both a 2 7/8 round shaft and a 3.5 inch round shaft. The 2 7/8 inch round shaft has an ultimate capacity of 100 kips, so 100,000 pounds in compression. Again, these are going to be on the quiz, so make sure you write these down. Also have a torque rating of 8,800 foot-pounds. That's the maximum amount of torque that you can apply to the pile. The 3.5 inch round shaft has an ultimate shaft capacity of 120 kips and has a torque rating of 12,000 foot-pounds. All right, so those are our main shaft sizes and load capacities. Now I want to show a brief video on our cross-lock advantage and why this is a superior connection in the industry and will save you a lot of time and be a better solution for your customers.
Round Round shaft helical piers offer superior strength and rigidity, making them the ideal solution for compression applications. The problem has always been making the connection safely and quickly. As torque increases, the holes begin to deform, causing further delays in the installation process. Consequently, the installer spent more time making the connection than installing the pile. This has always been an issue that the contractor had to live with. Until now. Introducing the patented ICC certified PureTech cross-lock connection. This connection goes together in seconds, containing all of the torque in the cross-lock coupling, so there is never hole deformation. Stop wasting time and risking injury. The new cross-lock connection will save you up to 50% in labor during installation. The magic is in the cross-lock coupling. The cross-lock connection instantly aligns and locks itself into place. Instead of fighting to line up holes in the connection and wasting time threading a bolt through a deformed hole. With the cross-lock, you connect and go. Safe, simple, and quick. PureTech is revolutionizing the helical industry by delivering zero hole deformation. This translates to less movement during installation and less potential movement after installation, providing superior stability and capacity in the helical pile. But what if a pile needs to be uninstalled or reinstalled? No problem. Because there is no hole deformation, the cross-lock helical pile quickly and easily uninstalls. It can be quickly and easily reinstalled. This is just not possible with typical round shaft helical piles. Our new cross-lock connection has been rigorously tested in the laboratory and in the field. Brian, a certified PureTech installer in Indiana, says, "The cross-lock connection blew me away. I'm now getting jobs done in half the time." The PureTech cross-lock connection offers a variety of benefits, including safer installation, instant alignment, zero hole deformation, increased torque capacity, superior strength, and lateral stability. Steel-on-steel connection. The bolts never see any torque or compression, and up to 50% in labor savings. It aligns instantly and eliminates hole deformation, saving you time and money. Choose the patented ICC certified PureTech cross-lock connection, offered exclusively by PureTech Systems. PureTech Systems, driven by innovation.
So that's our patented cross-lock connection. For more information, you can visit our website on that as well. But again, we're really innovating to help save you as the installer time and hassle. We have experienced that with our installers in the past, and that hole deformation that's experienced when you get to those higher torques, and how much extra time that really adds to the project. So that's the end of section 2. Again, I thank you all for joining. Make sure you click back on the Zoom link to join the Q&A section that will be starting shortly. And make sure you, again, if you've got a little bit of time left before it starts, jot down those questions or go back to any sections that you need to jot the questions down. And then once you get back, we'll do the quiz as well. So
All right, welcome back everyone to the second session, the second Q&A session. You can go ahead and start sending over your questions either from the first video or the second video, and I'll start answering those now. First question, in the boardwalk video, there was a diagonal driven as a brace. Was this a round shaft or a square shaft? The round shaft also work well enough in tension as opposed to switching to square shaft? That's a good question, Tony. Yes, you can use the round shaft in tension, and we use them quite a bit, especially for these battered piers, because the tension loads are relatively low and you're not as concerned about getting minimum depths of embedment. So the key with using square and tension, especially, is when you're getting up to the higher load levels, let's say in the 25, 30 kip load range, and you need to make sure you're reaching a minimum embedment depth. The square bar is typically a lot easier to reach minimum embedment due to its lack of friction on the corners of the shaft. So that was a question there from Tony. Hope that answers that question. Mike asks, how do we generate down pressure with the handheld drive head? So that's a really good question, Mike. There's a few different approaches on that. If you're going into a sandy material, typically the weight of the drive head and the pier is in the torque arm. All of that weight together is probably in the 250 pound range. That generally would be enough down pressure to start the advancement of the pile in the ground. And once it starts advancing and is in the ground about 3 or 4 feet, it'll have enough thrust from the advancement of the helix. If you're going into a hard clay, you're going to have to use down pressure from a number of methods. Foundation repair, if you're using a foundation repair for a handheld drive, you can use come-alongs and attach those to the drive head and then anchor bolt it into the foundation. Use 2 come-alongs on each side of the handheld down to the foundation, and then you can ratchet those to apply down pressure. That works best in a foundation repair approach. If you are in a new construction, you may have to use manpower to put some down pressure on it. You may have to use weights that you hang off of the drive head itself to gain some additional down pressure. I've had people use jack systems if there's a floor above the pile to add additional down pressure on it. So there's a number of different approaches you can take, but certainly for the foundation repair side, it's adding those come-alongs is the best approach. Next question: if you have to remove a pile and then put another back in the same place, you just install the pile deeper in the same hole to reach original ground? If so, how much deeper? So that's another good question. If you do have to back a pile off because you've maxed out the torque and you need to install maybe a smaller pile, you want to drive that pile all those helixes beyond your original depth. If you're in compression, if you're in tension, you want to drive them at least 3 to 5 diameters deeper, helix diameters deeper than the depth of penetration, to make sure that you have enough undisturbed soil above the helix to prevent a pullout of that pile. So again, if you're compression, you just want to make sure you're beyond that depth. If you're in tension, you want to make sure you have enough soil above to prevent pullout of the pile. And we can discuss that on an application by application basis. First video, the pier cap was embedded in concrete, did not show any welding or bolting of the pier shaft. Is this weld bolt attachment not required even in high seismic zones? Certainly in seismic zones, a bolted or welded connection would be required. That installation was here in the Midwest, and the The engineer did not require it to be bolted or welded. They just wanted the slip sleeve connection. A lot of structural engineers will require some sort of positive connection of the bracket to the pile. In those cases, tack welding, the bracket onto the pile, or burning a hole in the top of the pile and putting one bolt through is an option there. Again, a positive connection is just to make sure that that there is something holding that bracket to the pile, whether it be a weld or a bolt. Somebody asked, is it easy to determine uplift? Most everything is talking about side and down pressure. So yeah, uplift is generally required for retaining wall application, or let's say the pile is being used for a column where some of the piles are in compression and the other piles are in tension, or a cantilever type foundation design where the pile is acting as an uplift anchor. Retaining wall applications, any sort of guy wire anchor support, all of those would be an uplift tension load type application. And that's something the engineer should be calculating and telling you on your plans. All right, somebody asked, how do I add down pressure at an angle for a driver if on a gimbal? So down pressure can be difficult to add on battered piers. So you have to do a combination of movements and articulations with the arm of your excavator to put some down pressure on that drive head. This is going to take some practice and some skill from the operator to be able to apply that necessary down pressure. If we recommend that you try to get the pile to bite into the ground from a vertical standpoint first, and then once it's biting into the ground, then you can slowly back that pile up to get to your angle, and then hopefully at that point you've got enough embedment of those helixes that it'll bite and start screwing into and pulling the anchor in, and you won't have to worry about the down pressure. Once a pier is grabbing material and advancing, it creates more thrust than you're going to be able to keep up with. So at that point, it's just a matter of making sure you're following it into the ground. I've been on a lot of job sites where a piece of equipment actually started to be pulled off, the back end of it starts to be pulled off of the ground as the anchor's pulling it into the ground. So you want to keep an eye on that during your installation. I've got a question. Do you have your own engineers or have a list of PureTech certified engineers? Sometimes it's hard to find one when using alternative building systems. Yes, we've actually got a network of third-party engineers that we can refer you to that are licensed in most of the states in the U.S. So we've got one or two that has license in all states of the U.S. and then we've got a few others that we use that are regional. So if you let your salesperson know where you're located, we can refer you to that. PureTech does not stamp and do designs for specific projects. Just because of the large area that we cover, we currently don't do that. We're looking at adding an engineer to do that for large commercial and industrial projects, but we currently don't do it on a residential basis or anything like that. So if you need something, give your salesperson a call. We can hook you up. And also, if you've got a good local engineer that's interested in learning this and adding this on to their services, we would be happy to consult with them and give them the resources to become familiar with designing a helical pile foundation. So if you do have ones that are interested in bringing that on, we would be happy to get them educated in the system. Somebody asked if we can order Helix with V-cuts. You can order Helix with V-cuts. It does cost some more money, and the lead times are longer. But it can be done. If you expect it to, if you expect a project to have it, I'd recommend maybe doing that on the front end. Otherwise, it may be more cost effective for you to modify those V-cuts in the field, just because from us internally to have those special cuts made, it's going to add some cost and some lead time. All right. Any other questions? All right. So what we're going to do now is start the second quiz and third and fourth videos. We're going to share both of those videos, and you're going to do those back to back. The second quiz, again, do the same thing you did before. Save these links on your web browser so that you can come back to them. Once you're done with those third and fourth video, you can use this time to take lunch as well. So we're going to have an extended period of time here. Let me just look at these videos real quick and verify the timing on them. All right, so with the second quiz and with the videos and adding some time in there for lunch, we're going to have you come back at 3 p.m. Central Time, 3 p.m. Central Time to do the last Q&A session, and then we'll share that last quiz as well. So again, Nick just shared the quiz 2, section 3, and section 4 videos on the links. Make sure you click those, download those on your web browser, save them, and then you can exit the call. You'll have plenty of time to have lunch or make some phone calls and be back here by 3 p.m. So 3 p.m. Central Time, and we'll finish up the class at that time. And welcome back to section 3 of our helical pile training and certification class. In this section, we're going to cover some basic geotechnical information, design criteria, and go over how to calculate, go from load capacity to torque requirement for a particular type of pile. If you have a question, so a And welcome back to section 3 of our helical pile training and certification class. In this section, we're going to cover some basic geotechnical information, design criteria, and go over how to calculate, go from load capacity to. So a subsurface exploration, or a lot of you know it as a geotechnical report, it's very important to get and perform one of these tests whenever economically feasible on any project that a helical pile foundation is used. If you go to IBC, geotechnical investigation is one of the criteria for helical pile installations. However, it is at the owner's behest and at the building department's behest if they require this on lightly loaded or residential projects. So sometimes you won't have these available on residential projects or residential repair type projects, but maybe on a new construction application. Certainly, we highly recommend it for any commercial work that you may be doing. So during this subsurface exploration, the driller will be taking down information, and also the geotech engineer will be doing lab tests that will provide the helical design engineer with certain parameters to be able to specify the proper helix size and shaft size and depth for the project. The key component to this report is the boring log. There's a lot of great information that's contained within it after the drilling is done. So if you look on the right side, this is a typical boring log, what it looks like. It'll have the location, maybe the day that the bore was performed, along with the temperature, the start time, the end time, and any other relevant information, including soil classification, water table depth, and blow counts. And they'll show the whole soil classification throughout the whole boring log. So this will show where bedrock is, and it'll also indicate drillers' observations during the drilling process. This will be key to find out if there's any obstructions, cobble, debris, material that exists at the site that may cause issues with helical pile installation. One of the key factors within this, or sampling methods within this, is called the split spoon sampler test, or the SPT, standard penetration test. So this involves putting a sampler in the ground that will split in half, and a hole is drilled at selected intervals, a 4-inch diameter hole, typically with a hollow drill stem auger. The sampler is dropped in at specified depths, and it is hammered into the ground with a calibrated hammer. So typically it's dropped, a 130-pound hammer dropped 30 inches in the air onto this sampler multiple times until you reach an 18-inch overall distance of travel for that sampler. So every time the hammer comes down, that blow count is recorded. The final 12 inches of movement, all of those blows are added up, and that's what's called the blow count, or the N value. Generally, the higher the N value is, the denser the soil material is that you're going into. So this is something that the designer will use to empirically relate the capacity of the soil to then properly size the helical pile bearing plates. So it's really critical information that we look at as helical pile design professionals in indicating how deep the pile will go. Typically for a residential foundation load, you're going to see a blow count requirement somewhere in the 20 to 30 blow count to gain the capacity you're looking for those types of loads. And then it can vary depending on what size helixes you end up designing for the project. But using the normal size helixes, that's kind of the range you're looking for. Once you get beyond 50 blows per foot, you can have helical pile refusal during installation. So it's so dense that the pile reaches its maximum torque and it can no longer be driven. Also, sometimes if you have a very weak soil that has maybe in the single-digit blow count, and then all of a sudden it gets into a really stiff, hard material or a bedrock that's greater than 50 blow count, the pile can spin out or cavitate, stop advancement, and just rotate on that material. And then you'll have to adjust the down pressure to get it to rebite into the soil before it'll continue to thread in. So soil is classified generally by particle size, from smallest particle to largest. So if you go from the left to right, you have clays as the smallest, then up to silts, sands, gravels, cobbles, and boulders. And you can have a mixture of all of these soils together. And when the soils are mixed, the designer will run calculations as if the particles are cohesive in nature, meaning that they stick together, or cohesionless, like your sands and gravels that act as separate particles. The designer will run the calculations both ways to see which one is the smaller of the two results. This is part of the initial design process after the soil report is done. Again, this is going to be for the design engineers out there, not necessarily information that you need to remember as an installer. Corrosion is really a key factor when it comes to soils and how it affects the pile longevity and capacity. So the rusting process is a chemical reaction that decreases the life of the helical pile. Anytime you have a pile in soil or in air, that rusting process will occur as long as there's free oxygen available. So typically your highest corrosion area is between ground level and maybe 6 to 8 feet in the ground, where you have fill material and free oxygen available. That's your highest area for corrosion. The first type of corrosion protection is called corrosion allowance. And this is the thickness of the steel. It will have a sacrificial element to it. So with our smaller piles, we've built a sacrificial corrosion allowance within that steel itself, so that for an average soils, it'll corrode enough in 50 years that you're still able to get its maximum service life. So its maximum load capacity. So on average, your smaller piles are going to average 50-year service life, bare steel, in mildly corrosive soils. So AC358 is a independent accreditation process for the helical pile system, and they've established some criteria for corrosion loss. And what it says is that a bare steel pile will lose approximately 0.036 inch of wall thickness in a 50-year span. After 50 years, the PureTech 2 7/8 pile will have an allowable capacity around 50 kips. So you can design that pile to 50 kips. So that allowable capacity is also known as the working load capacity. So you can design it for that 50 kips after and be 50 years service life. So if you wanted to get more service life off of it, you'd start eating into your allowable capacity of that pile. So hot tip galvanizing is something that adds additional service life as well. So hot tip galvanizing is a chemical process where the zinc melds with the steel and chemically changes the outer diameter to create a protective barrier. And generally it's in the 4 to 7 mils of thickness. This type of protection is great because it works very well when you're installing into the ground and is does not what am I trying to say? Polish off while it's being installed into the ground, and it adds typically in that 25 years plus in the average soil conditions. Some soil conditions it'll add quite a bit more, and some it'll be quite a bit less. Other protective coatings are out there. So let's say you're putting in a marine pile into a lake or near brackish water. There are epoxy coatings and polyurethane coatings that you can add onto the pile after the fact that are higher, have higher abrasive resistance when you're going into the ground. So they're able to stay on there a little bit better. The great thing about these coatings is they encapsulate the steel and prevent it from corroding. So if you've got these in those applications where your pile is sticking out of the ground, you may have some maintenance over the years to reapply coats where it's worn away, but overall it's going to really increase the length of your pile in those types of applications. The last option is called cathodic protection. And cathodic protection would be where you either add galvanic anodes, like zinc anodes, similar to a outboard motor of a boat. So those anodes will corrode before the steel itself will corrode. And typically those galvanic anodes are added to a bare steel pile or an epoxy coated type pile versus a galvanized pile. And then the second is an impressed current. So that would be typically done on piles that are in the ground and are exposed, have a very large exposure surface area. So very large piles potentially, or areas that have maybe welding is being done, or there's some sort of DC current in the ground. So that's when you would potentially impress a current on those piles. So what some of the triggers that for more in-depth study would be really low resistivity. And resistivity is measured in the ground by, similar to resistance within a wire, you want to make sure you have a higher resistivity that'll lower the corrosion rate. If your resistivity is very low, it speeds up the corrosion rate. Also a pH. You want to have a stable pH ground. That'll help prevent the pile from corroding faster. So if it's unstable, you're below the 5 to 6 range, or you're above the 10 range on the pH level, you could have a high potential of corrosion or a higher potential of corrosion. And then the sulfate content. If you have a high sulfate content, that also will cause corrosion. Similar with a chloride content in the soil. High chloride content will then increase that. So these are all, or water content that fluctuates. So if you have a groundwater table that's relatively high and it fluctuates, it's going to have a much higher corrosion rate on the pile. So it's good to have galvanized piles in there, or maybe even encapsulate that pier with a concrete sleeve near the surface where you have that fluctuating groundwater level. All these are very important for looking at for more in-depth studies. And if you get into this, you'll want to make sure the geotech engineer understands this aspect of it, and you may have to hire a special corrosion engineer for a project that's in one of these areas that is very susceptible. All right, so I want to get into design and specification for commercial projects and what kind of things you're going to be seeing for submittals, and what you're going to be seeing required for the drawings, working drawings for the project. So the first part of the submittal is you're going to see that piles will need to be installed by an authorized installation contractor. So you want to make sure they're authorized by the manufacturer of the pile they're putting in. So that's what you're doing here today. Some projects may even require additional experience levels. So they'll want you to have experience on projects of similar size. If you don't have that and you're new to getting started, a lot of times PeerTech can be part of that experience, and we may be able to send somebody out to be part of the project with you at the start, to lend that experience side that's required in the submittals. Next, you want to make sure you have the pile design performed by a registered engineer in the state of the work that is being performed. So if you're in Colorado and you need a project done, you want to make sure you have a Colorado licensed engineer performing the work. If you aren't already linked up with somebody that's familiar with helical piers, we have a network of engineers we work with that we can refer you to that can perform that design submittal work that may be required on your projects. So please get in contact with your salesman if you have that requirement. Next, you'll want to submit a QA/QC plan. So you'll want to make sure that you're doing something to verify the material is what you ordered when it comes to the site. That includes measuring dimensions and lengths and helix sizes and all that to make sure that the material is what it is. And you want to be able to create that plan on the front end, submit it to the owner or the owner's representative so that they know how you're going to make sure that you're putting in the right material for that project. Next, potentially a load test program may be required in the specifications. If they're required, you want to put together what your load test program will be. And most specifications spell that out, what they want the test to be, how many tests they want, and what type of test they want. So you'll put that information in the load test program, along with the equipment that you plan on using and any sort of calibration certificates for that load test equipment. I talked about that in an earlier section, so if you need a refresher, go back to that first section, section 1, to refresh on that load test process. We can also get a little bit more involved with that with you when that comes up. Next is equipment calibration. So sometimes they'll require that the torque drive or the torque motor is, our torque monitor is calibrated for the project. And that calibration, they'll want that done within the last year of the project. So the best method is that IntelliTorque real torque monitor I talked about for calibrating this, for meeting this submittal requirement. So if you have that monitor, it comes with the calibration, you can submit that and you'll be good to go. If you have the pressure gauge system, you may want to consider getting one of the real torque IntelliTorque monitors to satisfy this requirement. Next would be stamped material cut sheets. So we'll provide cut sheets for the material we're doing, but they'll want them stamped for the state of work. That's part of the third-party engineers' scope of work. So they will then review those material cut sheets for this project along with their calculations and stamp that for the use on this project. And then we've got pile installation logs. So we showed an example of a pile installation log earlier. They'll want that log example in your submittal. And then for closeout submittals, you'll have to supply these pile installation logs for every pier that you put in on the job. This could be done the day that you do it or at the end of the project, depending on what the specifications require. Next, we have special inspections. Special inspections will involve either the owner or the owner's representative hiring out a geotechnical firm or somebody familiar with inspecting the helical piles that will go out and watch the torque gauges and write down the pressures and make sure that the pile is being installed per the specifications. And they'll also do a QA QC on the piles as well by measuring and making sure the pile material is what it shows on the working drawings. And they'll also verify depth of installation, the tolerances, the cutoff elevation, all of that key elements for installation. That's what the purpose of those special inspections are. Typically, you won't see a special inspection requirement for residential work, decks, foundation repair. Certain municipalities will require that, so make sure you check on that before you start a project, so it doesn't hold up your permitting or slow down your project there. If you're involved with it and you're dealing with an inspector or a building official on a residential project and they're really wanting the special inspection, we can talk them through that. Because you're being certified as an installer and you're using calibrated equipment, we should be able to get an exception for the special inspection on smaller, lightweight residential projects. Next is what the working drawing requirements are. So these will be the documents that you work off and you use to install the piers, locate, all of that. So first off, they're going to require the helical pile number, so all the piles to be numbered, show the location, and pattern by assigned identification number, so where those are on the specific plans. Then the design load, what the working load requirement is for that pile that's being installed. Sometimes that will be the same for every pile on a project, and sometimes every project will have a different design load requirement. The third would be the type and size of the central steel shaft. So if it's a round shaft or a square shaft, and if it's 2 7/8 or 1.5 inches, that will be specified on the working drawings. Then you have the helix configuration. We talked about that earlier. So you've got your single helix leads, double leads, triple leads. So that configuration, the number and the size of those helix blades will be written on the working drawings. Next, you have the minimum effective installation torque. So this is your target torque on the project. And you'll want to make sure that you meet or exceed this torque before you move on and stop that pile installation. So that will be something that's written on the working drawings. And then you have minimum overall length. So if they want you to meet a minimum depth of embedment, they'll say, we want you to meet 25-foot embedment. So you want to make sure that that's on the working drawings for every pile that you need to install. And then next you have installation or inclination of helical pile. Most piles will be installed vertical or plumb, but some piles will be installed at an angle. We call it a batter. So that angle will be required for piles that are taking up lateral loads, shear loads within a structure. And typically, sometimes you can see that angle anywhere from 5 degrees to 45 degrees, depending on the project requirements. If you're doing a pile at an angle, you can start the pile vertical, and then once you get it embedded a little bit into the ground, you can start pulling it towards the angle you're installing. So you start it out vertical, get it in 6 inches or so, and then start moving it out at an angle, so that once it's in there and you've got the right location, that it's not going to walk on you during the installation. And then you've got cutoff elevation. What elevation is the pile need to be cut off? How far up into the concrete pile cap or grade beam do they want that pile cut off? And that elevation will be part of the working drawings. Also, the attachment. How is the pile attached to the structure relative to the grade beam, column pad, pier cap, etc.? So that'll be another component. One other thing I didn't put on here was the tolerance. That's also going to be specified on the drawings. How far off of location can you be? It's very important to have an understanding of that before you go do the project, or else you could get installing a bunch of piles and have to go back and relocate and move some of those. So make sure you really plan this out before you start your project. All right, next we have material requirements. Sometimes a project may require an independent code council report, evaluation service report. called an ICC-ES report. This is an independent third-party accreditation company that certifies a building product for use in certain applications. We do have a ICC product for one of our pile sizes, and we're continuing to grow onto that as we advance. So please let your salesperson know if the project does require a ICC report, and we can get that information to you and get that right product quoted. Next, we have sizing helical bearing plates from a design standpoint. You know, how does a pile really function once it's in the ground? How does it transfer load? Well, there's really two methods it's transferring the load into the soil. One is by plate end bearing. So that's the right side picture here, the individual bearing equation. So the load gets transferred down through the top of the pile here, shown by the arrow. And then there's some side friction with the shaft, very small amount that's being resisted along the shaft. And as it goes down, the load transfers into each plate of the pile and bears into that soil layer. So this is an individual plate bearing. So very minimal skin friction, mainly bearing of the plate into the soil. The other way is called cylindrical shear, and this is the left side. So with cylindrical shear, you have the load coming down here in the area, same as before, and then the shaft in friction with the soil. And then when you get down here, the blades are spaced close enough together to where the soil creates a plug within that multiple flight pile. And that plug is within shear or skin friction with the soil surrounding it. So those are the two different ways that the pile capacity can be calculated. And the helical pile design engineer will run those calculations for both equations and take the lowest value of each one. So for those of you that want to get into this and understand this a little bit better, you can go to starting around page 24 of our engineering manual. You can read all about these equations and learn more about how these loads transfer in the pile. So there's other design considerations that go into designing a helical pile system. These normally play a very small role and are seen very infrequently on projects, but have to be considered. So the first one, shaft buckling. Shaft buckling can occur when a pile is in air or in a fluid soil. And a fluid soil would be one that has a blow count value of 0, meaning that when they drop the hammer down or set the hammer on that soil, it drops the 12 inches without any effort. It can't even support the weight of that 130-pound hammer. So that would be considered a fluid soil. If a pile is within that soil, it's acting like a column and it's not braced laterally from buckling. So buckling can become a concern. So anytime you see that in a soil report or your torque values essentially are nothing as you're going into the ground, you may have buckling concerns of that pile. So it's very important to get a geotech investigation and get a structural engineer involved in those types of soils. The solution to that problem would be increasing the pile diameter or potentially casing around the pile after installation. Both of these are acceptable methods to prevent buckling. Next, you have shaft adhesion. That is typically negligible on a small shaft diameter pier, but when you get into the bigger Hercules pier, you do get some skin friction out of the pile that adds to capacity. Next, you have pile deflection. Pile deflection is usually doesn't control on residential projects, commercial projects. Sometimes it starts to become more of a control. And then really when you get into sensitive equipment that you need very minimal amounts of deflection, that has to be accounted for in the design. Next, you have down drag. So down drag can occur when you have a very large layer of fill and it starts to collapse over time and add additional skin friction on the pile. So it's quite negligible with the smaller diameter helicals. Then we have group effect. Group effect occurs when piles are spaced close apart, so typically less than 3 feet. You start to get the piles bearing on the same material. And when that happens, the capacity is reduced because they're sharing the same soil. So as a general rule, you want to keep a 3-foot minimum spacing for a small diameter helical, something 12 inches or under. And then if you get closer than that, you want to put the piles at a slight batter so that the helixes are at least that far apart. That way you don't have to take or reduce the soil capacity. That's something to keep in mind when you get into some higher loads where you have to put piles close together. Typically column pads are the main areas where this comes into play. Next, you have pile load testing. We talked about that before. Here's an example of a very light loaded pile test, just two reaction anchors and a cylinder being loaded up. This is a verification method for verifying that you've reached the capacity you're looking for. Then you have expansive soils. Those are soils that tend to shrink when it dries and expand when it gets wet. So the expansive soils can cause a lot of problems with foundations if you have the helical bearing plates within that expansive soil. So you want to make sure you install those well below any expansive soil layers. Then you've got lateral loads. A small, slender helical pile will only resist maybe 500 to 1,500 pounds of lateral load, depending on the soil condition. So if you have to have higher lateral load requirements, you may have to increase the shaft diameter, encase it in concrete, or put the piles in at a batter to take up that lateral load. Again, helical piles generally are designed just for axial loads and not for lateral loads. But we know there are some light loaded applications like decks and small out structures that will require some lateral load. So you want to make sure you account for that in the design. And lastly, probably most important to make the project feasible is economics. So if you take all of these into account during your design, you can be very economical. Sometimes it looks expensive to have a soil report done, but it'll make the project cost less in the long run. Same thing goes with load testing. Usually the load testing will actually save you money on the project from an over-designed pile system. All right, the next thing I want to cover is the capacity to torque equation. Make sure you take good notes here and write down any information that you see, because this is going to be on the quiz for this section. So this is going to be very important. The capacity to torque relationship is an empirical formula that has been derived from hundreds of load tests that have been done on helical piers all across the world. So it relates the ultimate capacity to the helical pile directly to the final installation torque required to insert that pile to a given depth. So this equation can be found in 4.5 of our engineering manual, and we've got about a 2.5-page write-up that goes more in depth about how the formula was developed. So there's two ways of looking at the equation. The first one is, well, before I get into that, I want to get into the terms that are used in the equation. The first one is called QU, and that's the ultimate capacity. We already talked about ultimate capacity earlier. That's the working load times the safety factor. So the working load times 2 for most helical piles. And then you have the K factor, which is also known as the capacity to torque ratio. The capacity to torque ratio is specific to the shaft size you're installing. I'll show you here those on the next slide. And then lastly, you have T, which is the final installation torque. And that'll be something that you collect in the field as you're installing. So the first version of this equation here that I'm circling right here on the left side is going to be the main way that you're going to be using, or the main equation that you'll be using as you go about and do projects. So with this equation, you'll have the ultimate capacity that you've calculated by doubling the working load, and then you'll divide that by the shaft K factor, or the capacity to torque ratio as we call it. So that's the equation. You'll take your ultimate, divide it by K, and it'll give you your final installation torque. You can also look at the equation as if you're going out in the field and probing the soil and doing a test to figure out what the capacity of the soil is. So at a given depth, you can take a torque reading, and then you can multiply it by the K factor for that pile. And that'll give you the load capacity at that depth. So this is very handy if you don't have a soil report and you want to go ahead and test out a soil site condition before doing a project. All right, so the K factor, there's some common K factors for 3.5 inch and under shaft diameters. So for the 1.5 inch and 1 3/4, the K factor is 7. So it's typically a 7-to-1 relationship, or sorry, 10, a 10-to-1 relationship for the K factor on 1.5 and 1 3/4. And for the 2 7/8, the K factor is 9. So for every 1,000 foot-pounds of torque, you have 9,000 pounds of ultimate load capacity. And then you go down to the 3.5, the K factor gets down to 7. So it's for every 1,000 foot-pounds of torque, you have 7,000 pounds of ultimate capacity. As you notice here, as the shaft diameter gets bigger, the K factor goes down. Well, the reason for this is the surface area in contact with the soil becomes much larger the bigger you get. So you want to take out that false sense of torque from the shaft diameter. You want to really base it off of what the helix's experience itself. So that's why we're reducing the K factor as we get bigger in the shaft diameters. The K factor is less reliable, and based off the shaft size, it starts to become more specific on the soil condition and the helix blade geometry when you get into the larger pier shafts, the 4.5 inch and above. So typically either higher safety factors are used, or you go to a load test program to verify what that site-specific K factor is. So as an example, 7-inch OD shaft typically has a K factor in the range of 3 to 4. So for every 1,000 foot-pounds of torque, you have 3,000 pounds of ultimate load. So as an example, let's say you put 10,000 foot-pounds of torque on both an 1.5 inch square shaft and a 7-inch OD helical pile. So with 10,000 foot-pounds on a 1.5 inch, you have 100,000 pounds of ultimate load. But if you put 10,000 on a 7-inch, you're only going to have 30 to 40,000 pounds of ultimate load. So it takes quite a bit of more torque on a 7-inch to get to the same kind of load capacity. I hope that explains it. We can, if you have questions on this, we can write them down and we'll discuss it a little bit further in the Q&A session. All right, let's do a couple examples, some real-world examples. So with this first example, we are underpinning a residential foundation. So we're repairing it. And we've determined that there's a working load requirement of 25,000 pounds. So go ahead and write this down with me. So what we want you to determine is what is the minimum required installation torque. So I'm going to go through the step-by-step process, and this will be the same regardless of if you're doing a residential repair or you're doing a commercial construction. Step 1, you want to calculate the ultimate load. So think back to the previous section on how to calculate ultimate load. So ultimate load is simply the working load times the factor of safety, which is typically 2 for the helical pier. So ultimate load equals the working load times 2. So we take 25,000 pounds and we multiply it by 2. That equals 50,000 pounds. So we've now determined the ultimate load needs to be 50,000 pounds. We go to step 2. Step 2 is determine what is the required pile. So for this step, you'll have to go back to the previous section and understand what the maximum load capacities are for the different pile types, and also what applications fit them best. As you recall, you typically want to use round shaft for compression applications and square shaft for tension. So for a residential underpinning where you're supporting the foundation, that's a compression application. So you want to choose the round shaft material. Then you look between the 2 7/8 round shaft and the 3.5 inch round shaft. So the 2 7/8 has an ultimate load capacity of up to 100 kips, and the 3.5 has an ultimate load of up to 120 kips. So we've got an ultimate load requirement of 50 kips. That means that we can use either the 2 7/8 or the 3.5 inch. So you'd want to choose the 2 7/8 as it's going to be the least costly option. All right, so we're choosing round for compression application and 2 7/8 because it's less than 100 kips. All right, next we want to determine what the K factor is for the 2 7/8 pile. So for this, you determine the shaft size is 2 7/8. You go back to the previous slide and determine what that K factor is. That K factor is 9 for the 2 7/8 pile. All right, so the last step is calculate the torque. So if you remember from the equation previously, to calculate torque, you take the ultimate load, QU, and divide it by the K factor. So the ultimate load was 50,000 pounds for this project, and the K factor is 9. So 50,000 divided by 9 is approximately 5,600 foot-pounds. So if you're in the scenario and you've calculated 55, that will be difficult to precisely read on your pressure gauges, so you can always round that to 56, round it up to 5,600 in that scenario. All right, so we've taken our first run at going from working load to installation torque. I hope that everyone has a good understanding of that. For those who don't, we're going to go through one more example. And the same question are givens here. We're going to have the working load of 40,000 pounds for a tieback application. Question I have for you is, what is the minimum required installation torque? I'm going to go through our 4 steps again. First step being calculate the ultimate load. I'm going to give you a second to work this out. All right, so ultimate load is the working load times 2. Remember, 2 is the typical safety factor for the 2 7, or for the small diameter helical pier. So we've got our working load is 40,000 pounds times 2. equals 80,000 pounds. So 80,000 pounds is our maximum, absolute maximum ultimate load requirement for this project. Next, determine the required shaft size. I'm going to give you a second to figure this out. All right, for those of you who chose square shaft, you're correct. We choose square shaft because it's a tension application. We're pulling on the pile. And we discussed in our previous section what the advantages are of the square shaft for a tieback application. Next, we want to choose either 1.5" or 1 3/4". Now, the 1.5" has an ultimate load capacity of 80,000 pounds. The 1 3/4 has an ultimate load capacity of 100,000 pounds. You could choose either one, but I would recommend choosing 1 3/4 for this. And the reason for that is you never want to design the pile to its absolute maximum load capacity. I discussed that a little bit in section 1, but you don't want to overload a pile to the point where you don't have additional capacity in case you need to get through a hard layer of soil, and you don't have any additional torque in your pile to do that. So I would bump it up to the 1 3/4 shaft. If you chose 1.5", don't be upset with yourself. It's completely understandable of why you would choose that, and you'll learn over time that you want to be cautious when choosing the pile and keeping it about 20% or so away from its maximum ultimate capacity. Next, you want to determine the K factor. So I'll give you a second while you determine that. All right, so we know from a few slides back that the 1.5" and 1 3/4 both have the same K factor, and that is 10. So every 1,000 foot-pounds equals 10,000 pounds of ultimate load. Step 4, minimum torque. So now you can calculate your minimum torque. I'll give you a couple seconds to do that. All right, so minimum torque is simply the ultimate load divided by the K factor. So QU again is the ultimate load, and you divide it by the K factor. Our ultimate load for this project is 80,000 pounds, we determined from step 1, and the K factor from step 3 is 10. 80,000 divided by 10 is 8,000 foot-pounds of torque. That is now our minimum installation torque requirement for this project. So write these steps down. You're going to have to go through these same steps on the quiz. All right, next I want to introduce the pressure gauges. So in the previous couple examples, we determined what the minimum required installation torque is. And the units for that are foot-pounds of torque. If you are using pressure gauges, your units are PSI. So we have to have a conversion to go from torque to pressure, or from pressure to torque. So this is where this step comes in. This is called the inline pressure relief. This measures the differential pressure drop across the drive head using two gauges. The forward gauge, that's this gauge here, furthest from the valve, that's the forward gauge, and the back pressure gauge, which is the gauge closest to the valve. So when you're spinning in the clockwise direction, the pile into the ground, your forward pressure gauge should always be reading higher than your back pressure gauge. If it doesn't, you most likely have your lines reversed. So go ahead and switch those around if that's the case. Next, you calculate the differential pressure by taking the forward pressure reading and subtracting out the back pressure. So an example would be if you have a forward pressure of 1,000 psi and a back pressure of 200 psi, your differential would be 1,000 minus 200, which is 800 psi. So now you know how to calculate differential pressure. Now I want to show you the chart that relates pressure to torque. So this is an example chart for an old model drive, the RS12K. It has the pressure on the left side on the first column. This is the differential pressure. So this is the pressure drop across the drive. Then it has torque, and the torque is in foot-pounds. These two columns relate directly with one another. They can be directly correlated. So 1,000 psi of pressure, differential pressure, equals 4335 foot-pounds of torque. The same goes for 8,677 foot-pounds of torque equals 2,000 psi of pressure. So those two relate directly with one another. And then for sizing purposes for your drive head and determining how fast your drive head will go, we use flow rate, and this is the speed of your fluid flowing through your hydraulic motor in gallons per minute. And then you have speed of your actual spinning revolutions of your pier in RPM, revolution per minute. So flow rate is directly related to the speed of your rotations per minute. So at 20 gallons per minute on this drive head, it will rotate approximately 8.82 revolutions per minute. Vice versa, at approximately 15 revolutions per minute, you'll require 35 gallons per minute to get that speed. So that's how that drive head chart works. Now let's apply this back to our examples and go through to determine what our pressure reading requirement is for a particular torque. So remember from our first example, we determined a torque requirement of 5,600 foot-pounds. So now you're out in the field and you're installing the pier. You've determined your back pressure for that machine is 300 psi. And you're using the RS12 drive head, the chart I showed in the previous slide. So this 300 psi may or may not be what your specific machine will end up having when you get it, but I'm giving you this as an example. It'll be somewhere in the 50 psi to maybe 500-600 psi range will be your machine back pressure. So the questions I'm asking are what is the differential pressure, and what should the forward pressure gauge be reading on your inline pressure relief? So this is going to have a step-by-step as well. The first step is find the installation torque value on the drive head chart. So our installation torque value is 5,600 foot-pounds. So on the torque chart, 5,600 foot-pounds falls between 5635 and 6069. So between 5202 and 5635. You want to round up to the higher of those two values, the 5635, and read off the corresponding pressure, as that is 1300 psi. So at 5635, the differential pressure requirement is 1300 psi. So you now have what that difference between the forward and back pressure gauge is. So now you want to determine what your forward pressure gauge should be reading. So this differential pressure of 1300 psi is what you'll determine prior to going out to the project. So you now know that you need to reach 1300 differential psi. So you go out there and you're installing with a 300 psi back pressure and a target of the 1300 differential. You will simply add the differential pressure to the back pressure. So 1300 psi plus 300 psi gives you a forward pressure gauge requirement of 1600 psi. One check is your forward pressure should always be the highest reading when you're going into the ground. Back pressure should always be the lowest reading, and the differential pressure should be in between the two. Let's do another example. So in this example, we go back to the second part of that first set of questions, where we determine the installation torque to be 8,000 foot-pounds. We're now out in the field and our machine is getting 200 psi of back pressure, and we're using the RS12K model drive head. So we need to determine what is the differential pressure and what is the forward pressure gauge reading. So I'm going to give you a second to determine the first step. So the first step is find the installation torque value on the drive head chart. All right, have you found it? It falls in between 7808 and 8677. You want to round up. So from 7808 and 8637, you round up to the 8637. You go to the 8637 and read off the corresponding differential pressure, and that is 2000 psi. The third step is to calculate your forward pressure. So to calculate forward pressure, you take your differential pressure of 2000 psi and add the back pressure. Back pressure is 200 psi for this project, or for this specific install. 2000 plus 200 equals 2000 ps. Incorrect. 2200 psi. It's a mistake there. We'll adjust that. So this should be 2200 psi. All right, so that's the end of section 3. We'll be back here shortly with Tech's training and certification class, the online class. This is section 4, marketing your business. Here at PureTech, we don't charge territory or franchise fees, sign-up fees, anything to install the product. So we really think that your business, you know your markets, and you know how much you should spend on marketing budget. So we don't dictate that, but we do recommend you take the money that you're not spending on those fees and invest it. And if you follow some of these strategies we're going to talk about here in this section of the video, that you will be successful in gaining more projects and more leads. So really, we take 3 main marketing attacks and components. First being the lunch and learn. Those are the face-to-face interactions that you have with potential clients. Then print media. That'd be anything that you could hand over to a client to leave them with your information or send out as mailers. And then really the third and biggest one right now is digital marketing and having a good digital footprint. So the lunch and learn, there's a lot of great ways to do a lunch and learn. You really want to start off by inviting as many people as you can and getting them into the event. and creating a experience. So bringing somebody in, offering lunch, and educating them at the same time. So here's some tips for a good lunch and learn. Make sure that when you do the lunch and learn, you get everyone's contact information. So if you're going to an architect's office and presenting, make sure you get all the business cards you can for everyone there. You never know who's specifically going to be interested in it, or when a retargeting effort will spark a potential project. You want to create good responsive slides. So in the presentation, make sure you're doing slides that will get people to respond back to you and ask questions. You also want to present yourself as the expert. Don't cover more material than you have knowledge or are capable of presenting. So when you start off, you may start with a short lunch and learn, 20-30 minutes, where you show a couple of videos and answer some questions. And again, if you don't know the answer to the question, it's okay to say, let me get back to you on that, and then follow up with them later and answer that question. Also, again, remember it's always better to over-invite than under-invite. So scan your whole network to make sure you're inviting the people that would find this information relevant and applicable to them. And then make sure you remind before the event multiple times so that people don't miss out. As people's schedules get busier and busier, it's easier to forget about events, especially if they're events that you offer out as a free event. And lastly, follow up. So after the class is over or the lunch and learn is over, follow up with them and see if they have any follow-up questions or need any more information or potentially have projects that you can work with them on. So lunch and learns are really great if you're in the commercial realm. You're dealing with general contractors, architects, and engineers. This is a great way to share that information with them and get them interested in your product or your service that you offer. The second prong is the print media. So print media is great to hand out at a lunch and learn, or maybe drop off at an engineer's office when you drive by, or at a potential client's office with a quotation, so that you can show them, hey, here's something on hand that I can see, and see the process and see how it works, what the end result's going to look like. Also mailers have become a lot more popular now that emails are being spammed on a daily basis, that mailers are actually becoming more effective. Typically people only get maybe 4 or 5 pieces of mail, and they're more likely to look at it and read it when it comes through. We offer a lot of different print media brochures that we have available. We can send you PDF copies so you can print off locally, or we can print them off for you at our cost. Contact our office if you're interested in that, or your salesperson. We can get you linked up. All right, the biggest component and the most complex marketing side nowadays is digital marketing, and making sure that you're out there and you've got a good digital footprint, so that it's the biggest net from a marketing standpoint. You're going to reach way beyond your capabilities when you get into digital marketing. So I know a lot of you probably work on word of mouth marketing in some of your businesses, and maybe you're in a small close-knit community where that works. Nowadays, the younger crowd is getting more and more focused on digital interactions, and they're not doing a lot of face-to-face communicating. So you want to make sure you've got a presence on there so that that younger crowd can find you when they need your service. Really, when it comes to information, we used to get our information from the encyclopedia, but you don't go back to those encyclopedias now. You get on the internet and you Google something, right, to find your information. So you want to be that source of the information for people so that they come to you if they have questions. You don't advertise anymore in the Yellow Pages. Yellow Pages used to be huge for advertisement. Now people advertise on the internet because that's where people are looking for information. And that's where they know the majority of companies are. So you remember, you want to be where where the most interactions, you're going to get the most bang for your buck from a marketing standpoint. So everybody can remember Blockbuster Video. Never thought that, back in high school, renting Blockbuster Video movies, that someday that business would be out of business. And really, they didn't keep up with the times. So they had the mentality that, people are going to continue to rent videos and drive and go pick it up. And then Netflix came along and said, well, no, you don't have to leave your house. You can rent them here. This is the same way it goes with internet marketing and website marketing. It's an easier, quicker way to get that information. So what's the digital foundation? Well, it really starts with websites. So the website is the key component, and from the website, it can be a basic website. It doesn't have to be anything complex. Then you get down and you want to have your business verified through the different search engines. Business verification allows you to get localized searches. And then we have video. So videos are great. They allow people to stay on your website longer and gain information quicker than you can by reading it. So videos really help with converting. And then other key digital properties. These include a lot of the social media aspect with Facebook, LinkedIn, Instagram, also Home Advisor and Angie's List. A lot of these are other key properties where people can find you and find your company. The Better Business Association, all of that. Then you get into nurturing those relationships. So once you've gained those contacts in, you want to make sure you stay in touch with them and nurture them with information on products and new services and potential webinars, sales, anything like that would be part of that nurturing the relationship. So a study was done on the digital attention span, and this study is maybe 7-8 years old now. It said you have 59 seconds to grab someone's attention. Nowadays, it might be 10 or 15 seconds. So you want to make sure that you don't clutter up your digital marketing or your website with a lot of wording and long paragraphs. You want to make sure that you're grabbing somebody's attention quickly so that they are interested in your product and are going to stay on your website longer and eventually give you a call or fill out a form. So an effective website is going to have 3 key components. So this is what makes it profitable. Bold headlines. So make sure your headlines are bold and say something about your company. Clear services. Like this over here on the left side, the authority for helical peers. We're a helical peer company. And simple calls to action. If you want a phone call, then make sure you put your phone call on the web page, on every web page. If you want somebody to fill out a form, give them that option to fill out a form. So there's a lot of simple things you can do with websites to make them more profitable. Again, remember, you don't have to have a long, complicated website. A couple pages is all you need. So here's a visual on a couple of websites. One, you see a clear, distinct picture. You've got the clear headlines. You've got calls to actions down here, free engineering manual, locate an installer, video gallery. All of that is within that website. Now you go to this left side, you'd have a difficult time figuring out where to go on this or what they're doing. What's the service that they're offering? So this is really a good example of a clean website versus a kind of a cluttered website. Next is business verification. You want to make sure you get your business verified through Google and the other search engines. Here's an example of what a localized business listing looks like on Google. So on a web browser like on a PC, you'll have your your localized search. Let me go back to that real quick. So you'll have your localized search up here on the right side. You can see PureTech, where we're located, the business address, all of that information on the right side. And then on the left side, you get the advertisements and then the organic search results. So this localized thing will only happen with people that are searching in your area. So if you're able to verify your company address with Google, you'll get one of these localized searches with keywords that are associated in your website. So if you have helical piers in your website and your business is verified through Google, when somebody types in helical piers locally, this verification will pop up. All right, here's what it looks like on a phone. So a lot of people are looking on their phones nowadays, and if they're looking on their phones and they're doing a localized search for a service, something, a product, what's going to happen is they're going to see these local results first before they ever even get down to the ads or the organic searches. So this is really key to make sure you get your company present on these local searches. So the power of local means up to 50% of local businesses generate by maps. So, this is maybe a little heavily skewed by the food industry and some retail stuff, but if you are offering a product locally and you don't have your business verified through Google and you're not listing the products and services you offer on your website, you're not going to show up and you're not going to get a part of this business. Next, you got video marketing. Video marketing is very important nowadays. So nearly 75% of internet traffic is from videos. YouTube is now the #2 search engine in the world. Users will spend 88% more time on websites with videos. So that means they're on your website longer and you have more chance of capturing their information. In fact, you have a 30% higher chance of capturing their information with a video on your website. Again, those videos don't have to necessarily be long and complex and heavily produced. You can shoot a video with an iPad or an iPhone and show the before and after of a project and explain what you did. That's as simple as it has to be. Next are key properties. So key properties are all those social media and auxiliary digital marketing platforms that you can be on. So it's good on these websites to do before and after pictures. Make sure you show some work that you did, and that's going to relate with people as they see, especially in the foundation repair business or anything residential where you've got the end users on there and they're looking at that and seeing how it goes. Or if you're a commercial contractor, you should be on LinkedIn sharing your commercial projects you do and what this innovative technology has done for that project. Those are big. You can also use it to show customer reviews. So people that don't know you, they can quickly relate to you because one of their friends is reviewing your services and can see that you're a reputable business and have done a good job for them. Next. Next, you have lunch and learns. Make sure you send out lunch and learn invitations, through your social media channels. That's going to get more action and more people in. And then your video white papers. And a white paper is essentially a case study or a technical paper about a service or product you provide. So putting those video white papers or case studies on your website, on your social media channels, are going to help drive traffic to your website and eventually to you with projects. So next we have nurturing. Nurturing is key to growing and developing your website and growing your customer base to bring them back to you. So nurturing involves offering webinar and lunch and learns, offering specials and referral programs, giving out success stories and white papers and newsletters, different content that is bringing people back to you and keeping them in touch. So when that next project comes up, that they think of you to do it. Again, it's keeping you at top of mind for that customer, that end user. All right, next we have the organic side of things. So when it comes to Google, there are nearly 2 trillion searches a year on Google. So 72% of local searches result in a visit. 93% of users start with a search. So they don't start by typing in your website. They start by typing in a product or a service that you may offer. And then 75% of people don't scroll through the first page or past the first page. So it's really key that you develop your website so that you can be on the first page of Google. These are really strong stats that show you the power of investing in your website, investing in your search engine optimization for your website, and getting advertisements through Google. So the difference between the first page of Google and the second page of Google means 5 new jobs a month. So that's not 5 phone calls or 5 form fill outs. That's 5 jobs a month. And this is specific to the foundation repair industry in a market of around, let's say, 2 million people. So with this, you're talking about at an average maybe of 15 grand, 20 grand a project for a foundation repair. You could be making an additional $100,000 a month simply by showing up on the first page of Google for those key search terms. So organic nature of Google and building your website organically means that you'll stick. So it's very sticky. It's powerful. It also delivers a lot more leads than purchasing ads through Google. You receive more clicks than any other digital advertisement out there still. So if you're doing ads on Facebook or doing any other type of digital marketing, you really don't receive as many clicks or views as you do by being on a search engine, your website on the search engine. And next, it keeps you in front of your customers. So if somebody ever forgets about your service that you offer and go back to search, well, they can find you again and find your website quickly by making sure that you show up on that first page. So if you're new to creating a website and you don't have that long-term standing to get you on the first page of Google, you can do it right off the bat through AdWords. So Google AdWords is really simple. You pay money per click. So every time you select a word like helical piers, you pay for that word, and somebody clicks on it, and you pay a certain fee, whether it be $1 or $2 or $10, depending on how popular that search term is. But that means that you'll show up at the top part of Google, and get immediate access to those search terms. So advertisers on average across all of Google's search terms make 100% return on investment. When it comes to industries like helical piers and foundation repair, you're going to see somewhere closer to 500% return on investment. So if you put a $5,000 in, you're going to get, 5 times that amount, or $50,000. So next, you've got 30% of users will click on the ad. So 30% of those users that search will then click on your ad. So you gain access to those people. Again, Google Ads gives you immediate access to competitive searches, and also they're highly targeted to your exact specifications. So if you want to target a certain time of day or a certain zip code or demographic of age range, male, female, whatever, you can target it through Google AdWords. That's a very powerful thing. So that's our marketing talk, and that's the end of section 4. Just make sure you remember, invest in your business. If you invest in your business, you're going to be successful. You're going to gain more leads and projects, and you'll be quickly paying off the equipment investment that you've made, and growing that sector of your business. So if you go ahead now and return to the Zoom call, the Q&A session will begin shortly, and we'll be wrapping up. Thank you very much. Hello and welcome back to the final Q&A session training today. I hope everyone has found some benefit here and will find this useful moving forward. Before we get into the Q&A session, I just want to make sure this before people, before we share the quiz and jump off, make sure that everyone in your company that would like a certification has filled out their registration paperwork and also a quiz, all 3 quizzes. So it's very, very critical. Your certification will be held up until that information is received. We'll let you know if we had any issues with the quizzes, not passing that, and let you know so that you can retake those quizzes. So we'll go ahead and start the Q&A session. Make sure you turn your video and your cameras off. Again, just out of confusion. All right, so the first question I had was, at what point do you determine your machine back pressure? And does the machine's back pressure remain the same? So that's a good question. If you're using our inline pressure relief block that has the forward pressure gauge and the back pressure gauge, you will determine the back pressure throughout the installation. So that back pressure will occur throughout the installation. Again, just a reminder to everyone, please keep your cameras and your volume off. So on your machine back pressure, and I apologize, I just pulled off there so that I could mute them. You'll be constantly watching both your forward pressure gauge and your back pressure gauge, and then making the differential calculation throughout the installation. Your back pressure, for the most part, should level off as long as your machine RPM remains constant. If you're adjusting your throttle and your flow, that will adjust your back pressure. Your machine may also become more efficient or less efficient when it gets up to the higher pressures. So your back pressure may drop or may increase at that point. So it's a good idea to keep an eye on the back pressure gauge to make sure it's not changing drastically. Can capacity and torque equation be used for most soils? What are examples that it does not work in? So yeah, the capacity torque equation can be used for most soils. It tends to, again, you can't use it for fill materials, materials with organic content, even some extremely soft clay material, silty materials tends to underreport capacity in a lot of instances when you get into those materials. So just keep an eye on that. Philip asked, do these work in frozen soils? Recommendations dealing with heat transfer. So they do install in some light initial frost, but a heavy freeze deep in the winter, you'll probably have to do some pre-augering of either the pile shaft or the actual helix diameter itself to get the pile to bite into the soil. Otherwise, you're going to sit and you're going to spin out, or you're going to need to thaw the ground out at that initial point. As far as heat transfer for permafrost, for those instances, you may have to do some additional heat transfer elements from the pile, and I can show you some case study information. We don't get deep into the design of that, but I can refer you to some case studies to look into that a little bit deeper. How far below grade can and should you encase a pile for corrosion prevention protection? That's a good question. When you mean encase, I'm assuming you're referring to encase the pile in concrete. That has to depend on the soil conditions that you're going into. If the soil has a high, if it's we talked about that tidal zone for coastal installations. That area near the surface is highly affected and increases the corrosion rate. So those are areas where you need to encase the pile. Normal conditions, you would not need to encase the pile the length of the or into the soil. Normal non-tidal areas, non-coastal areas, you would not need to do that. Are project designed for brand specific piers or by specs? Yeah, some projects are designed for brand specific piers, but most specifications you're going to see will do an improved equal. You're probably never going to run into a project where they're going to say we'll use this brand of helical pier and nobody else's. So generally we should be able to become an alternate if there's another brand of pier specified. Somebody asked the approximate cost range for the IntelliTorque monitor. That unit runs around $7,000. The internal strain gauge when it gets calibrated, that calibration I think is somewhere in the $1,000 to $1,500 range. And that IntelliTorque is good for up to 30,000 foot-pounds of torque. So if you get a larger drive than 30,000 foot-pounds, then we'd increase the size of that IntelliTorque. Is galvanizing with zinc anodes redundant? It can be. It just depends on the service life you're looking for out of the product. The zinc anode is a continual thing. You can replace those continually for however long you want to. With the galvanizing, the steel, once that galvanizing's gone, you can't recoat the steel with galvanized. You can't redip it in the ground. So that's the cases where you need long service lives. That's where the zinc anodes come into play. Somebody asked what the competitive edge over other helical piles. For you as an installer, one of the big competitive edges is how quick you can install the pier with our crosslock connection. We also have higher torque ratings than a lot of the competition, so we can put more load capacity on piers. Getting projects done quicker, allowing you to do more projects, that's going to give you a competitive edge, allow you to price products more competitively. The higher strength yield product that we do also is a better engineered final solution, so it allows us to put more load capacity on the pile, have a longer service life. Those are all big benefits to our product over another brand. So we asked, do we have any information or packages to help advertising and bidding? We do have some brochures for helping with advertising the product out there. And then as far as bidding the work, we'll assist you with bidding the work. So when you get the projects in and you want to bid it, send the information over to your salesperson and we'll help work with you to bid that project most effectively. Are pressures only to be read after hydraulics have reached operating temperatures? How are pressures affected? Yes, you would want to make sure your machine is warmed up because consistent machine temperature can affect your pressure readings. So yes, you do want to have your equipment warmed up, especially if you're working in winter. That's important to make sure you're getting good pressure readings. Somebody asked about difficult conditions to install piers. Certainly rocky conditions, areas with cobbles and rocks and fractured bedrock. it can be difficult to install a pier end. You could have a difficult time gaining the torque capacity necessary. So in those locations, if you want to use helical piers, I recommend staying on the low end of the load capacity. With the 2 7/8, maybe somewhere in the 5 to 15,000 pound range, so that and build in some redundancy in your foundation, so that if a pile spins out, you've got enough capacity with piles next to it that it won't cause issues in the foundation. If you really anticipate there to be a lot of cobbles in the ground, the piles may just not be the best option for that site. So it's something you got to think about with the site you're dealing with. Somebody said if they spend 5,000 in AdWords, how much can you expect back? Brad, I would say that is highly dependent on your location. If you're in a major metropolitan area, I would say you spend $5,000 in AdWords, you can expect to get $60,000 to $120,000 worth of business out of that. If you're in a small area, remote area, you might not see that kind of return. So a lot of that is going to depend on how big your market is. What's the price for small drive heads? The smaller drive heads are going to range in that anywhere in the $4,000 range up to $5,500 for the drive itself, not including any of the attachments, anything like that. And as you get bigger, the cost will go up from there. Scott asked a question about using the drive head with an auger. You certainly can use the drive head with an auger, but you're going to run at a lower speed than you would traditionally do with an auger. So it's not the most efficient way to auger a hole, but it can be used for a couple piles here or there. We do sell augers as well. So if you're looking for a quote on those, reach out to us as well. Other questions? How do you judge recommended depth without a borehole? Can I rely only on torque to find ultimate capacity? Yeah, if you've got good knowledge in the area and the type of soil that you're going into, then you can gain some knowledge from that. Or if you have empirical experience in the area on depth to good ground. I mean, those are really your two major things. If you don't have that borehole and you've got a larger size project and you're really trying to get a good estimate, we recommend going out there with a helical pile and probing the site for torque, and that can be a good indication of capacity. So you'll go down and you'll install a couple test probes and use that information to come up with a estimated depth and helix configuration. I want to ask you guys also rent your installation equipment. We do offer rental options on installation equipment. Typically, if you want to rent the equipment, it's going to be as much as a third of the cost of the overall package. So usually it's something that's done for larger jobs, or maybe if you have one type of drive head and you need another just for one project, we usually rent for those instances. What is the most common setup for foundation work? residential foundation work. I'm assuming you mean foundation repair. The foundation repair, we've got a couple different gimbal style side mounted drive heads, the MM10K and the 12 DLSG. Both of those drive heads attach from the side, and you can, it helps with overhead clearance. So if you have to install underneath a porch or a deck, you can get in there with that limited clearance. We definitely recommend having something with a little bit more reach when you're doing residential repair, because getting through an excavation or around something that may be in a yard, having that reach is really useful. Any other questions? So this last question, I'm not fully comprehending, but if you're putting a 2 7/8 pier into the ground, you're going to determine capacity based off of the installation torque. So that's how you're going to determine what the pile's capacity is. What is the smallest amount of overhead clearance required? The most compact helical drive head. So the most compact drive is our handheld drive head. It requires about 2.5 foot worth of clearance, plus whatever your pier size is. So we can make some pretty short sections. I think 3 foot is the most common short section that we can make. So you're at about 5.5 feet would be a pretty tight, compact area. We have done some crawl space installations with shorter sections and where they actually dig out a little bit deeper into the soil to help with that. But yeah, you're probably about that 5.5 feet range. Questions about the quick connects. I think that's about the excavator hookups. So our excavator hookups, range from, 1,500 to a couple thousand, depending on what equipment you have, what the make and model of your equipment is, what's your attachment there. But we can custom make those excavator mounts for virtually any excavator out there. Oh, the crosslock, how much is the crosslock? The crosslock comes pre-welded to the pile. So it's already part of the pile cost, the crosslock connection. All right, any other questions? All right, so I am going to have Nick share the last quiz with everyone now. Once you copy and paste that quiz into your browser, you can go ahead and log off the Zoom call. Appreciate everybody's time today. Please reach out to your